Hi everyone and welcome to day one of 3D Crowd Talks. For our first talk we've got Ed, Claire and Isla talking about Enable. And I'll hand over to you guys.
Hi everyone. Welcome to this talk. We just wanted to talk a bit about how we've used 3D printing to help people before 3D Crowd, the project that we were doing. And we wanted to run through that. Just to quickly intro us, my name's Ed Gregg. I'm the Chief Disruptor for Deloitte, and also got Claire here.
Hi everyone, so I'm a director in Deloitte, focused on infrastructure, construction and real estate.
And we've got Isla as well.
Good morning, everyone. My name is Isla Thomas. I'm a consultant at Deloitte Digital, and I'm a researcher in experience.
Lost Isla slightly there. But anyway, it says what it says. Yeah, the user research and experience. We have David, I think, might be joining us shortly, but David's the partner and the project lead for this. So this project came out of the disruption team, which I lead within Deloitte, and our motto as the disruption team is fall in love with the problem, not with the solution. So that's something that is kind of at the heart of everything that we do. And
sorry, I'm in here.
Oh, hi.
I think she might be moving to get a better signal.
Yeah, good. So she is falling in love with the problem, not with the solution, which is excellent. So that our way of working is fall in love with the problem, not in love with the solution. It's very much about kind of user-centered design and working that way. And I think what's been brilliant is that 3D Crowd has really also fallen in love with the problem, not with the solution, in terms of, the problem was how do we get as much PPE as possible into the hands of the NHS. And I think 3D Crowd did that really well in terms of kind of being agile and stuff like that. So we really liked that. So with regards to 3D printing, though, well, actually, I'll stay on that side, because we wanted to. One of the problems that we were interested in as a disruption team was this idea that the NHS was not using new technology as effectively as it could be. And one of the areas that we thought was interesting to explore was this idea of 3D printing and 3D printing prosthetics specifically, because it seemed like the difference between what was achievable in terms of cost versus what kind of traditional prosthetics were currently costing was so big that even if we didn't create something that was absolutely 100% efficient, we would still see kind of tangible benefits from the work that we were doing. And so we printed some prosthetics out to kind of test that and to sort of explore this idea, but they were just tests that we printed off. And once we had done that, I gave a talk similar to this, and that was actually where I met Claire. Do you want to chat a bit about what happened then, Claire?
Yes. So as I said, I'm in infrastructure, construction and real estate. And a couple of years back, when I first joined Deloitte, I went to a 2-day event with the firm that different people came into the room around modern technology and how infrastructure, construction and real estate were evolving. And one of the people who walked into the room was Ed. And he did an hour session and he brought some 3D printed hands with him. And he started passing the hands around the room for us to all have a look. And when I realised that I was going to actually hold a 3D printed hand, it started to have a really profound effect on me, because I had a 5-year-old niece, well, she's 9 now, and she was born with a limb difference. And Phoebe, out of the NHS, has been offered passive limbs, so limbs that don't do anything, and just really demoralizing to see them. And it's not a criticism of the NHS, it's just in terms of the best offer that there was at the time. So it was either hook hands or hands that don't do anything. So as these hands started being passed around the room, then I started to cry, and Ed came rushing over and asked why it was having such an impact on me holding a hand. And I said, because I've been waiting for a moment like this, in terms of somebody making hands that are just inspiring to a little girl. And he said, don't cry, Claire, shall we make her a hand together? And so that's how we started on this journey. That evening I went home to my brother and his wife and Phoebe, and I said, I've met this person, Ed, would you like to start coming on this journey and have Deloitte make a hand for you? And she said, oh, Auntie Claire, that'd be amazing. And so that's how we started.
Yeah, and so it was the start of a really amazing journey for us. And so first thing we did was we had Phoebe come down to our digital studio, and we explained to her about 3D printing, and we showed her some 3D printed stuff. And then the first thing that we did was we printed off a just a white plastic hand, and sent her some felt tips, some Sharpies, so that she could color it in herself. And because another motto of ours is, think big, but then start small and test often. So kind of work iteratively. And that's what we were really trying to do here. So we sent her this to kind of test this out. And that seemed to work pretty well. And so then we sent her a template in order to design her next hand. And we told her the printer could do 2 colors at that point, which we could just about manage by switching filaments midway through. She drew this in response. This is actually Princess Poppy from the film Trolls, in case it's not immediately obvious. Her mum was also told that the printer could do 2 colors, and sent us an actual rainbow, which was we are used to clients not necessarily listening to what we say sometimes, but this was a special moment. But so we took some artistic license with that, and we printed off this arm, which was the kind of the Princess Poppy arm, which you can see here, and you can see Phoebe using the hand here. So this is her brushing her hair with that Princess Poppy hand, which was a really nice moment to kind of see for the first time. And I mean, it's been wonderful to be kind of part of the WhatsApp group where Phoebe and the family have kind of shared these videos, because there's been some really, really special moments in there. And so we kind of made some further modifications and adjustments to the arm, so added in the finger grips. And I think this photo for me is a really special one, because this was the first time that she'd taken the Princess Poppy arm to school. And going back to this idea of falling in love with the problem, not in love with the solution, the great thing was the initial problem that the hand that you saw at the beginning, the hook hand, solved was, how do you make a good functional prosthetic? But that's not really the problem that you need to solve. The problem you need to solve is, how do you make a functional prosthetic that a 6-year-old, in this case, actually wants to wear? Because the hand that she had previously worked fine, and it would survive if you dropped it, and it had good grip strength and everything like that. But it spent all of its time in a drawer. And one of the things we say is there's no innovation without adoption, and so that is that was what was kind of really crucial. And so this for me, the fact that she's accessorized the hand with her hairband shows such a shift in terms of her relationship with her arm, which I think is was really exciting. So then from there, well, she did. We then, this is her matching it with her outfit again. We then created a number of other designs because we wanted to keep iterating. Isla, do you want to talk a bit about the other designs that we created? I didn't actually include all of the photos of you working on the designs because I thought you might not be happy about that. So I've just included the designs themselves. Oh, I think you're on mute, Isla.
I am being absolutely schooled, aren't I, with the mute, non-mute? Yeah, absolute schoolboy, rookie ever. Yeah, so yeah, as Ed said, we went through a few different iterations in quite a short space of time, I suppose. We got a super cute video through from Phoebe on the WhatsApp group saying, I want one like Frozen and Princess Elsa from Frozen. So that's what you can see on the screen here. We sent that off to Phoebe and we got a really good positive response. She was saying, yeah, lots of kids were pretty jealous of her Princess Elsa from Frozen arm. But then we also got feedback that Phoebe almost liked it too much, that she was a bit worried about wearing it in case anything happened to it. So that's when we created this rainbow or rough and tumble arm quite quickly after, so that she had two arms. So hopefully she felt less scared about using her one of the more decorative arms like the Princess Elsa from Frozen. I think we also did a unicorn arm as well. Oh yeah, you can see it there.
She still uses that now.
Yeah, we did the unicorn arm as well. I think my mum helped to put that one together as well. I've got a nice picture of my mum sat at the kitchen table helping me file away some of the parts, because as we know, the parts don't always print as smooth as we'd like them to, especially when they're touching skin of a young girl. So yeah, and we also did some more experimental versions as well, ones that we just found on the internet that we thought we'd give a go. Phoebe gave some feedback that she wanted to be able to bend her wrist, so we used a different design that we found online just to see what kind of leverage Phoebe could get from bending her wrist. Obviously, when we iterate and we experiment, often that ends in a massive fail. But if you don't try, you don't know. So. Yep.
And then, I mean, one kind of big moment for us was when we were as kind of part of the project, Phoebe was able to lead out the Manchester United team. And you can also see there Max, who was one of the other children that we were working with. And we actually, so we started to grow this and work with more and more children who we contacted, and this, I mean, this came about through our contacts in the Northwest, didn't it, Claire? The
yes, it is. So yeah, we there's been at times, you know, first off, I just want to just reconfirm, if you like, I can't tell you the impact that it's had on our family in terms of having these hands made for Phoebe. Phoebe was diagnosed with a limb difference in the womb, and one of the things that devastated our family, just as an example, was, will she be able to shake hands? And the impact upon us on the first hand that Isla and Ed sent, in terms of Phoebe put that hand on and was able to shake hands with my brother. You know, as a family, we were in bits watching that moment. It's so precious to us. The other aspect is the school moment when Phoebe used to wear the hook hand and she would hide her hand under the desk. And then when she received the Princess Elsa hand and the Poppy hand, you know, this was a moment to shine and to show it off and have some envy off her friends. You know, they're just awesome, priceless moments for a little girl. Moving on to the Manchester United opportunity. So we are a Manchester United family, and our sports team in the Deloitte Northwest office heard about about the hands that we were making. That's my home office as well, and Phoebe's from Manchester. And so they wanted to get around us in terms of saying, is there any way that we can give Phoebe a bigger platform? And then yes, we'd started working with Max by then, and he was a massive Manchester United fan, and I was chatting to her mum and Max and said, is there anything that we can do now? You've got the hand, and it's a Manchester United hand that he asked us for. And she said, his mum said, wouldn't it be amazing if he could walk out on the pitch with Manchester United? And I spoke to the sports team, and before I knew it, we had the exec of Manchester United saying, would Max and Phoebe like to be mascots for a day? Honestly, it was just magic moment. And we all went, didn't we, to watch in the crowd.
I'm a Spurs fan, so the one walking out was great. The following 90 minutes was
a challenge.
But it was fine. I got through it. Yeah, no, it was great to have you. That was fine. It was what was on the pitch. And kind of as part of that, we started working with an organization called Enable. So a lot of the designs we had come across through Enable, which is kind of a global network of 3D printing volunteers who their service basically matches people who have printers with people with limb differences. So we started to work with them. I think that though, as we started to scale it up, another thing that we realized was that as kind of a large organization, it was going to be necessary for us to get a regulatory approval, which is something that everyone at 3D Crowd is obviously very familiar with. And so we kind of went through that process. And David, would you be able to talk a bit about the regulatory approval, the process that we went through for that?
Yeah, sure. So I guess, we were going through the internal processes of getting formal approval for us to do what we've done, sort of on an unofficial basis. And our legal guys advised us that actually this was a medical device. And after many arguments of whether it was a medical device or not, we came to the conclusion it inevitably was. And I guess the context for this is that we really saw the magic that we were doing with Phoebe and with Max and with other children. And we sort of were developing an ambition to scale this into a much, much bigger thing where we get lots and lots of volunteers like we have in 3D Crowd, and lots of kids who have the need, and kind of connecting them together and kind of really getting going from tens of children to hundreds of children, thousands of children. And in order to do that, we had to make sure that we were fully compliant. So we went through the process of understanding what that would take, and we've now, after a number of months, got kind of the systems in place and ticked all the boxes so that we can actually produce these devices that are fully medically compliant. So we're just about to restart now and to start producing these in a way where the regulator is comfortable with what we're doing, and obviously once we can do that, we can start building the base of makers and really pressing the button on finding more and more patients, recipients, children, whoever they may be, adults or children, where we can help and build these things for them.
Do you have the Kwawu hand? I forgot to, but do you have the Kwawu hand there with you or not? So the Kwawu one.
This room, I can certainly go and get it.
Well, yeah. Sorry, I should definitely have asked before, but yeah, the one.
I'll go and get it.
Okay, cool.
And one of the reasons why David is making the Kwawu hand, which we're all getting our heads around saying that word, I am anyway, is because Phoebe, Isla and Ed are always asking for feedback off Phoebe, and Phoebe requested, because her wrist doesn't do this, then that was the next design challenge that she's set the team. And so this design has just recently become available. And so this is Phoebe hasn't had this hand as yet, but this is the next iteration to try this design on her.
Yeah. So would you be able to quickly show us that? Yeah.
Yeah. So there's the Kwahu hand, I guess. Big difference is there's a tube rather than thermoformed forearm. There aren't rubber bands on this anymore. The hinges are actually rubberized. And most important for Phoebe is the ability to
twist the
turn the. Where are we? There you go.
Yeah.
Yeah.
To be able to turn the hand like that. So that was quite important for her. She's had a first version of this. The other thing that we're doing with this one, which we hadn't done with previous hands, is that we found a rubberized paint. So we actually paint the fingertips now, and they are grippy without having to slide on the silicone thumb covers. So a number of things changed, but so that's the Kwahu hand.
So she's had a first version, hasn't she, David? But it was just to see if she liked the colours and the design. But we've not actually, you know, the family, like as an auntie, I'm holding my breath looking at that, because when she puts that on and can have a hand on the left side and do that with the wrist, like that little WhatsApp video will just be magic again to see, because that'll be the first time where she can do that. Yeah.
We also talked about the regulatory compliance, and if I zoom right in here.
Yeah.
Oh, up a bit, David. Just
this is the sort of thing we are having to do. You can see that printed on the device is a serial number and the name of the recipient. So those are the sorts of things that we have to do to kind of comply with the regulation.
Yeah, and I mean, well, similar to what we're going to have to do within 3D Crowd in terms of having the month and the where it's printed on the CE compliant ones going forward. So a familiar story for 3D Crowders. So, I mean, I think one of the things that's been really interesting is definitely the community, the enabled community is quite a technical community. And I think that actually there are quite a lot of makers in the community. I think one of the things that they've struggled with is actually kind of outreach and the demand side of the supply chain, which is why I would encourage makers to get involved, but actually all of the everything that we've done in 3D Crowd around contacting healthcare workers, contacting hospitals and things like that, those other parts, apart from kind of the making itself, all of that coordination piece, I think is really vital. And I think we need more of that in the UK for Enable than we have at the moment. So if you do want to get involved, feel free to reach out to us, but also you can join the Enable Prosthetics channel on the 3D Crowd Slack, and we would love to have you involved. As I say, both makers and also people who would like to do the coordination piece as well, because I think that will be really, really important for us. So, so yeah, we're pretty much at the end of our time. Sam, what's the situation with questions?
So we've had some questions in.
Oh, we have had some questions in. Oh, cool.
One from Mayan about what material was used to print the arms, and was it comfortable for Phoebe to wear for long periods?
Yeah, so I mean, I can take that. I mean, we have always used PLA. It looks like that David's using some Sunlu silk there. In terms of comfort, we did have to make some adjustments to the straps on the Team Unlimited design in order to make the straps kind of thicker. We've kind of evolved it as we've gone along with the with comfort and stuff. We have looked at foam inside the arms as well. So yeah, it's something that we continue to evolve. But I think she's able to wear it for fairly long periods now. What's the kind of right now, Claire, how long? I know, well, yeah, in terms
Well,
of
it depends. So it's usually she goes and finds a hand when she wants to do an activity. So like holding a golf club. So it's like playing in the garden is when we see her wear a hand, or on a Wii, you know, holding the nunchuck, is it? And, you know, needing two hands to do that kind of thing. So as long as she's playing the Wii, like 40 minutes. But it's very much, it's a tool to her. So when she wants to do something that needs two hands, she will go and find it. So it's a choice.
And I think that was actually something that was really important when we started the project. We had a colleague who has now moved on to another firm, but we had a colleague with a limb difference who was involved in the project at the start, and actually she was really good, because she said that when she was younger, the prosthetics had been pushed to her as a way of making her normal, as somehow fixing her. And she was very adamant that this should be regarded as a tool, not as a somehow a fix, or filling in something that was, because she said that basically put her off prosthetics for her entire life, because of that, the way in which it was kind of presented to her and kind of pushed on her. And so actually, as Claire says, that idea that this is a tool rather than somehow kind of a fix, I think is really key.
And I'd just add to that, actually. So Dame Sarah Story, the Paralympian, so she lives near us. We got to know her when my sister-in-law was expecting Phoebe, just to get some support off somebody with a limb difference. And she's just been giving feedback around these hands. They're so inspiring. I wish they existed when I was a little girl. And so that's been awesome to get that kind of feedback off a role model such as her as well.
Any other questions, Sam?
Yes, another one from Peter about how they're actually controlled by the wearer.
Oh yeah, that's a great question. They're elbow operated, so either elbow or wrist operated, and they're mechanical. We did at the start look at kind of bionic hands, in the sense of like robotic or motorized ones, but what we found was that the mechanical ones were actually much more reliable. So basically, when you bend, well, David, maybe you can show with the. Can you show with the Kwawu? Or is it
I can, but the lines aren't installed at the moment. But essentially, the lines are attached to the grip here on the bicep, and then they run down through the hand. And essentially, by moving this joint here, that opens and closes the fingers here.
And I mean, interestingly, we've worked with we've worked directly with, I think, 27 children and one adult, and the adult actually did have a prosthetic that was controlled via myoelectrics, and he found it incredibly hard to use because it wasn't configured to him. He had to learn how to use it, so he had to learn how to tense his muscles in a way that activated the myoelectrics. And he said it was just so unintuitive, and he really struggled with it. And actually, when he came into the office, the first thing he did after he put on the arm was picked up a glass, and he said, I haven't been able to do that. He also shared other stuff that he's been able to do with it as a result of the arm, but it's not certainly not for this time on a Saturday morning. But yeah,
some of our recipients are very open.
Yeah, it opened up a whole new world for him, basically. But yeah, so that mechanical one, we've just found it does the job and it's more reliable. I do think that ones like Open Bionics and things like that are definitely where we would want people to go. But when they're at this sort of young age, because the youngest we've built one for is Autumn, who's 4. At that sort of young age, I think it's better to have a mechanical one. It's easier to fix, all of that sort of stuff, but it gets people used to the idea of wearing an arm, so that they're comfortable kind of using one later on if they then decide to switch to a motorized one.
Another one was that the heavier, whereas these are really light.
Yeah.
for the children. That was another difference. I remember one child saying to us.
Yeah. Yeah. Any other questions, Sam?
Yeah, so there's one more about whether you'd consider setting a design and manufacture challenge for kids in school to engage in prosthetic limb development, and maybe giving out a user profile and allowing everyone to develop a variety of concepts.
Yeah, I think that's a brilliant idea, and I think now that we've now that we've got through the regulatory approval, I think that's the sort of thing that we're looking to do. Enable in the US have run a number of kind of assembly projects for kids and stuff. So they've had kids assembling the hands, which is it can be fun, can be painful. I think we wouldn't have the kids filing because Isla still has the scars from some of her filing incidents. But yeah, I think that, but yeah, also being able to do the design stuff as well, I think is great. There's another project that we've worked with who are called, I now can't remember what the name of the project we worked with that provides kits to developing countries, which was
I'll find the name.
I'll post it on the screen later on. What was that? What were they? But yeah, so yeah, there's been a couple of things we've been involved like that, but yeah, it would be really nice to do something kind of off the back of this. I think that would be brilliant.
Team benefit.
Team benefit, right? Yes, cool, great. Well, we're a little bit over time, I guess, but yeah. So thanks to everyone for listening, and really we would be so keen to kind of direct some of the amazing kind of power of 3D Crowd towards this project, because as I say, as Claire has alluded to, it's so special and has such a big impact on families. So it's a wonderful thing to be a part of. And I think there's a lot of opportunity for both makers and for people who are interested in kind of coordinating this project and helping to kind of raise awareness of this within the UK to do stuff. We have also been in conversations with the NHS off the back of this. Those conversations have stalled somewhat as a result of the pandemic, but we hope to be able to kind of resume those conversations once things have calmed down a little bit. So yeah, it's an exciting project, and we'd love to have you involved.
Great. Well, thanks very much to all of you. I really enjoyed that. Yeah. So coming up next, we've got Michael's talk about work in schools, and that will be at 10:45. So our next 3D Crowd talk is from Michael Noonan, who's going to talk about design and technology education and how they've responded to the COVID-19 national PPE shortage. If you've got any questions, ask them in the comments below and he'll answer them at the end. Over to you, Michael.
Thank you very much, Sam. So as mentioned, my name is Michael Noonan. My talk today centres around design and technology education and the role that it has had in responding to the PPE shortage nationwide. So, overview here today, I'm going to be talking a little bit about my story, about how we got started with this whole effort and how design and technology departments came together to try and collaborate and to try and cooperate so that we could respond adequately to fight the coronavirus. We're going to talk about the evolution in terms of how this initiative grew exponentially over the course of the 12 or so weeks we've been doing it. I'm going to talk about the 3 designs that became standardized for all design and technology departments to use. We faced quite a few challenges throughout the course of what we did here. I'm going to talk about how we overcame these challenges and the types of solutions that we developed for them, our lessons learned from the experience overall, and although we're not finished, what we've learned from the experience as we've gone on, the overall outcomes of the experience that design and technology departments have delivered, and then what I see as being the future in terms of future collaboration between design and technology departments having engaged in this particular effort. So a little bit about my story. I qualified in Ireland in 2013 as a woodwork and construction studies teacher from the University of Limerick. And like most of my peers at the time, I had to immigrate because there was little or no permanent job prospects at the time in our country because of an ongoing recession. I'm very interested in developing technologies and in additive manufacturing, particularly in recent years in 3D printing and robotics. I'm a bit sports mad, really. I'm very interested in rugby and in GAA, fitness and podcasts, as well as traveling when permitted, obviously not at the moment. And I'm a Chelsea fan. So myself and Ed might come into conflict with our differing football views. My motto to live by is that, and this is one I try and infuse really in our students in school, is that hard work trumps talent if talent doesn't work hard. And I'm paraphrasing slightly a famous basketballer called Kevin Durant. I've been working in Queen Elizabeth School since 2013 when I immigrated, first as an NQT and then going on to become a permanent member of staff, then becoming an extracurricular enrichment tutor before taking over the head of subject role almost 3 years ago. Since taking over, I've implemented a 5-year plan to try and upgrade the department facilities and to bring it into line with modern technology, particularly focusing on the implementation of 3D printing and robotics. DT in recent years in our school has gone through something of a renaissance. It surged in popularity from when it was previously on the wane. This is largely because of updates to the curriculum, a changing in teaching style, a massive upgrade in our facilities, and then success in the extracurricular sphere as well. We are a highly successful department, both academically and in the extracurricular world. We have been world robotic champion and numerous national champions about 4 times now. We've won many engineering competitions and competed in many engineering competitions, such as the Engineering Education Scheme. We massively promote the Arkwright Scholarship as well by the Small Peace Trust. So, taking a look at our starting point. Where we really got going was the day that school closures were announced here in the UK on the 18th of March. I can remember it very clearly. We were in the workshop with about 40 or so students and all of our staff members here in the department. At the time, we knew that there was a government briefing due at 5 o'clock, and so we decided to show it live to the students in the department. I think they may have had a bet going as to when the school closures were going to be announced, so they were very keen to find out. And when it became clear to us that we were going to have to close on the 20th of March, we had gone from what was really operating at 100 miles an hour peak time in terms of our role as a design and technology department to suddenly coming to an almost complete and total stop. Students, teachers, there was a great feeling of almost helplessness and powerlessness amongst everybody in the department. And the immediate feeling amongst my colleagues and I was that there must be more that we can do. In the following days, I started to do some research into what people were doing to try and aid the coronavirus situations worldwide. I saw the prolific 3D printer, Josef Prusa, inventor of the Prusa 3D printer in the Czech Republic, had begun production of 10,000 units for the Czech Ministry of Health in Prague. I also saw that Colin Keogh, who's an engineering lecturer in UCD in Ireland, had begun working on an open source project on a variety of different strands, from ventilators to face masks, to try and aid the situation in my own country. I saw that Copper 3D, who are a distributor and maker of both 3D designs and 3D printing filament based in Colombia, had started to create their own mask as well. And all of these examples had commonality in the sense that it was about sharing expertise. It was about sharing these out so they could become crowd projects. It was about everything being open source so that anyone could access it if they had the appropriate tools and expertise. And it was about being not for profit so that there could be a difference made to the situation. Initially, having seen some of these examples, I decided that I would try and make the Prusa design, the RC2 at the time, and the Copper 3D mask just for staff members in school. As we had announced closure on the 20th, we were due back on the 23rd for an all-staff briefing in terms of what the arrangements going forward were. And many staff members had expressed an interest in getting some of this equipment from me for any future teaching in whatever shape that might take. Over the course of the weekend between closure and coming back, it dawned on me that if we were to form a group or an effort or some form of a banner under which all DT departments could operate, we could pool together our resources and expertise, and we could make a much more significant difference nationwide. It was at that point that I started the design and technology education against the coronavirus, against the spread of the coronavirus group that you can see in your center image there. Initially, it was just about inviting friends, spreading the word amongst colleagues past and present, and getting DT departments with whom staff members I was personally familiar with involved so that we could make a difference in our own area. It was posted online to Twitter. It was shared on Facebook in many of the other main design and technology groups, such as the Data and World Association of Technology Teachers groups. And the starting point really was posting online of links, of advice, of plans in terms of what departments had already started doing, in terms of what they had seen online, sharing ideas, particularly design ideas, and any other resources we could. It was at that point, when I was researching resources to share online, that I came across the open source COVID-19 project, as previously mentioned, that involved Colin Keogh in the UK and Ireland. And it was from that group that I managed to spot a Slack invite for what was at the time a fledgling 3D crowd. Having joined in there, I immediately got the feeling, it was in around the 25th of March at this stage, that this group seemed to have a very coherent plan, seemed to have great collegiality, there was great direction in terms of what was happening. There seemed to be an awful lot of industry experts, and I decided that this was certainly the mast I wanted to nail my colours to, and that I wanted to get my department involved with. At around this time, both of these groups began to grow exponentially. Movements began nationwide, commencing in that week after we had started closure of the schools. There was agreements to speak with press about what we were doing. Other departments were reaching out to try and get publication of it. And in around that time, as a result of David Sims's talk with the BBC, my own foray into media duties with the Times, lots of other DT departments and makers sharing and liking and doing as much publicity as they possibly could in terms of sharing the efforts that we were doing. There was a huge surge in membership of both of these groups. That then leads us to the evolution of what happened next. Teachers all over the country began making masks, visors, and equipment, such as door openers. They began donating PPE to hospitals from PPE that they had in-house for their own departments. For instance, we donated 500 sets of eye protectors from the DT and science departments to our local GP trust. At this point, because of the efforts of so many different departments with a variety of equipment and a variety of expertise, we saw many different designs beginning to appear, satisfying the needs of those people who had been inquiring for them. Right from the off, the Design and Technology Association, through Tony Ryan, their CEO, and Ryan Ball, who was an educational trainer there, were involved with the effort. They were tweeted early on, and they wanted to help coordinate with the control of what we were doing in the group. They wanted to help create guidelines, which meant that quality could be controlled and assured from DT departments. And we wanted to really ensure that we could uphold high standards for all of our departments so that what we were doing was safe as well as practicable in helping with the crisis. Tony and his colleagues began to contact their local MPs to lobby nationalising this effort through the Department of Education. The thought process was that of the 5,000 or so DT departments nationwide, we could suddenly transform them into a production line where there was already massive shortages in PPE, and we could become an auxiliary manufacturing company to help those who are already stretched to their limits. At that point, recommendations and best practice began appearing online in our group. Schools began dedicating entire departments to their effort, ensuring that enormous scaling up of efforts and contacts were being used outside of the department with industrial partners, but very careful and conscious effort to maintain social distancing within the departments was done at that time. And they were also ensuring that they were wearing PPE and cleaning the PPE themselves. We began to see hospitals ordering directly from schools instead of from their suppliers, initially in quite small volumes and then with an enormous increase in volume, with the example in the bottom right-hand side getting an order of 500 in their very first week. It was at this point that we decided that 3 designs had to be settled upon. The snippet that you can see at the very top of your screen there is from CLEAPS, who are an advisory board for DT and science departments. And they had suggested initially, as I'll mention in challenges, that production should stop, but eventually they decided that in collaboration with DT and many other experts around the country, 3 designs could have been decided upon. The 3 designs that you can see are the 3D printed design on the left-hand side, which is the Prusa RC3. The major advantage of anyone working with this, in terms of a DT perspective, was that there was an SOP in place which ensured that everybody adhered to the same practice guidelines. This was a huge reassurance for DT departments all over the country, with whom there was a slight worry in terms of liability should there be any faults with these. The one that we see in the middle was designed by Roger Newman and a former colleague of mine, Charlie Munro, working in Birchwood High in Bishop Stortford. They, on their first day of production, were able to make 200, and they were quickly able to scale up production to about 300 a day. It used a combination of machines, riveting, line cutters and laser cutters. And although it involved a bit more manpower than some other designs, they were still able to produce more than enough for their local COVID hot centres and hospitals. This design was adopted by quite a few departments all over the country because of the lesser demand on equipment. What proved to be the most popular design is the design we see on the right-hand side. This was designed by Smoke and Mirrors, who are a laser cutting company who work in collaboration with Kitronic, who are an electronics kit, education electronics kit company. That design was purely based on laser cutting. The transparent shield that you can see the man wearing in the right-hand picture and the polypropylene headband that you can see him wearing, there is no external components. It's all laser cut. It's very easy to tessellate onto large sheets of material, and speed was absolutely brilliant with that design. So that quickly became a very popular design, also because laser cutters are more widely available than, for instance, 3D printers in departments. Some schools immediately became able to produce in very high volumes and at a higher pace, especially when they combined more than one of these designs. The way it tended to work was that the laser cut and the handmade designs in some cases went to local key workers, when the 3D printed design with the very specific SOP went to COVID hot centres and hospitals, who were really in need of very exact and well-controlled PPE in terms of the hygienic practices being used. So our challenges that we faced, as previously mentioned, CLEAPS initially advised in the document you can see on the right-hand side in their online publications that DT departments should not produce PPE. They were quite right, really, with this recommendation because of the potential liability that people could face if there was any complications in terms of the quality of what was being produced. However, through later collaboration with both data and the subject experts, as mentioned, with things like the SOP that 3D Crowd were able to present and other safeguarding measures that the other designers were able to present, they changed their guidance to reflect that there was 2 or 3 recommended designs that could have been stuck with. The next challenge that we began to face was that of material shortages, and this was an enormous challenge for the 3D Crowd printers, the DT departments and makers all over the country. Departments began using it faster than it could be delivered or than it could be bought. Data reached out, as well as some other teachers, to some industrial contacts to source donations of materials at a huge scale, and this began being sent out. On the top right-hand side, we can see that Dentford donated 450 reels of PLA to be shipped out to 3D Crowd, and in the bottom right-hand side, This is a tweet from Kidtronic to say at one point, after purchasing an excess bulk of polypropylene, which was for making the visors for the smoke and mirrors design, they had sent out enough material to make 1 million visors. The next challenge that faced many departments was the speed at which they could produce these designs. Although they were doing their absolute utmost, and in many cases working around the clock to produce the PPE required for their local NHS centres, demand was still far exceeding supply, which was something common that we also experienced with 3D Crowd. Some innovative and some very savvy heads of subject at Merchant Taylors and Oakham School, who are Andrew Duffy and Timothy Weston respectively, they used local and alumni contacts in the flooring and injection molding industry to massively scale up their operations. And what they did then is they collaborated with other schools so that teachers who didn't have any of the equipment capable of manufacturing the PPE shown in the earlier slides could get some of these laser cut and mass manufactured laser cut and injection molded designs, and they could assemble them together, they could package them up, and they could send them to their local NHS centres despite not having the equipment. In terms of numbers, Merchant Taylors in partnership with Amtico Flooring were able to produce about 20,000 a day. Over the course of about 2 weeks, they managed to make somewhere between 60 to 100,000. Oakham School, which is Timothy's school in Rutland, partnering with Rutland Plastics, managed to produce around 30,000 units, which they sent out to local centres all over Leicestershire and Northamptonshire. The next challenge that many of us faced was cleanliness and social distancing, and maintaining this within our DT departments. However, the DT departments themselves, given their size and scale, as well as schools with facilities such as sports halls and large classrooms, turned out to be the perfect space which could be used, especially over the closure of the Easter break, where there was very few staff on site, which could bring potential contaminants into where you were working. The image that you see in the bottom there is my own food technology room, which was used as a cleaning station when we changed our hub into the role of cleaning hub. You can see the face masks drying all over the room there, being hung into the kind of dish dryer areas. Out of shot are the basins that we purchased for cleaning these in the Milton solution. So, and obviously the room itself is ventilated in terms of an external power source anyway. So really an awful lot of schools around the country had the perfect facilities in-house right from the off for helping out with this. Some schools which use these departments, as mentioned, Merchant Taylors and Oakham, but also Parliament School here in London, St. Paul's Girls' School, Great City Academy, Belmont Prep School, and our own school, Queen Elizabeth School, used their and dedicated their DT departments to this effort over the course of this time. In terms of lessons learned, we learned that one platform is best for all. Slack worked extremely well for 3D Crowd and for the tech-savvy makers, but it was quite hard to convince teachers who were already operating on Microsoft Teams, on Zoom, and many other platforms to commit to using this. So what we found to be a more effective tool for communicating and coordinating the school's effort was the Facebook group, and in some cases using Zoom with our own 11 students who were making here for us in school. We also learned that variety brings a major challenge to production. The variety of machine, of setting, material, expertise, and staff in hand proved to be a major obstacle. But the platform of the Facebook group that we established was a major advantage in this sense, in that people, in as nice a way as possible, would advise each other on best approach. We also learned within that group that best work really needs to be highlighted, and we saw some incredible efforts from schools who highlighted manufacturing units in the thousands and thousands all over the country. And this, in turn, helped to foster healthy competition, a communal work ethic, and encouragement to continue on. We learned that shared wisdom is more powerful than keeping that wisdom at hand, which we saw from many of our experts sharing their advice on the variety of machine and setting. And we learned that partnership is key in getting your voice heard. Our partnership with Data, which brought forward partnership with the Royal Academy of Engineering in securing materials and prominence in terms of our voice. And then our partnership with Need to Chat here in Barnet, for instance, with the delivery of our face shields all over the locality, and our fantastic partnership in the London area and nationwide with the Bike Shed MCC in terms of collection and delivery of the parts that we were making. In terms of our outcomes, on last count, 356,000 units of PPE had been made, donated, and sent to healthcare practices worldwide. This was done on the 30th of April. the poster that we see on the right-hand side. So my estimate is that the real number is certainly in excess of 500,000. We were able to use this crisis as an opportunity for an educational tool. Conal Kelly, a teacher on our group, created a resource based on all of the efforts that he was able to see from the various efforts of schools around the country. And we were able to set challenges from some of our students to mock up the same actions that we were doing. School children who had printers at home, such as those in Haberdashers, QE, St. Paul's Girls, and one particular student in my own school who made over 600 units on his own, they were able to get involved in the effort, and they, which was an enormous advantage for them, got to experience what life was like in a fledgling manufacturing company and understand what it would mean to help those around them with their skills and experience. We were also able to show those students the role which engineers could have in improving the world around them, which after all is the core principle of becoming an engineer. I believe it had an incredible outcome in terms of the reputational gain for design and technology. For instance, where we can see the Independent article on the left-hand side quoting that 200,000 pieces of PPE for frontline healthcare staff had been made by DT departments. DT itself has been a subject in decline, but the hope is that the efforts of the teachers and the departments nationwide and the impact that they've had can produce an increase in popularity and relevance for this subject. Another outcome is our manufacturing and our introduction as an auxiliary supply line and an auxiliary PPE company when those who were tasked with that particular job were exhausted in terms of their resources and materials. Our advantage was that we were able to innovate and alter our designs to suit our end user on a bespoke basis and based on the materials that we had in hand. In a sense, we were the ultimate QRM, quick response manufacturer model, and the publicity that we gained with various different sources managed to publish our ability to do that. As mentioned, the partnerships were an enormous advantage for us, and many DT departments all over the country will look to continue to promote that and continue to bring that to hand to show students the power of partnerships. And over 530 members joined our group worldwide and were able to share their ideas. We had teachers from America, teachers from Argentina, teachers from Australia sharing their ability to help out in this particular challenge worldwide. We now also see in terms of outcomes that a model exists where DT departments can quickly collaborate and respond to global crises, and that the history of what we've done here won't be forgotten. And one of the key aspects, one of the key advantages that we've gained from this is a huge resource gain for schools in need, not just in terms of knowledge, but also one of our main manufacturing hubs here in London, which was the Cisco Meraki hub in central London, which was headed up by Patrick Coleman, kindly donated 20 3D printers to schools who couldn't afford to 3D print or didn't have the facilities to 3D print with this effort. They're also hoping to share knowledge of these machines, but most critically of all, they're helping them to establish a STEM curriculum which can be enriched by the provision of these machines in their school. In terms of where do I see this going? So as mentioned, the resource and knowledge gain for schools has been absolutely incredible in terms of how we can help us. Educational collaboration with 3D Crowd and the Design and Technology Association is something that I would love to see. I'd love to see, as mentioned in the previous talk, the setting of potential challenges for students using some of the resources and models that we have developed and what we've done with 3D Crowd and Design and Technology, giving talks and linking experts with schools. I hope that in the future there's a renewed faith in DT as a subject and in its popularity, an increase similar to what we've seen in our own school, and that the relevance and the skills of DT are really made obvious to students now. I hope that future global challenges such as potential pandemics, as mentioned in the previous talk, the need for prosthetics, also the sustainability challenge for everyone in DT, that group projects can now easily be collaborated and dealt with in a well-equipped and savvy group and a quick timescale. Competitions and challenges such as those set by Autodesk and Tinkercad are a way of encouraging students to get involved with this. I hope that we can continue to use the valuable industrial context that we've built up to deliver talks and set challenges as mentioned, but I believe that the main gain in the future of DT here is inspiring the next generation for the difference that engineering can make, and also knowing that in our actions and what we've done, that we've been able to do our bit and play our role in helping to protect the NHS and other key workers during this time. So, thank you very much for listening, and if you have any questions, I'd love to hear them.
Thanks very much, Michael. So we've got one question from Elle about what other projects do you use the 3D printers for in school?
Sure. So probably we use them at almost every age group now. I mean, a few years ago, it would have been the sole resource for A-level students, but now we have year 7 students designing chairs on CAD and 3D printing them, year 8 students designing F1 cars on CAD and 3D printing them. Year 9 students this year, we're actually designing for end users with maybe disabilities or certain needs, and they were 3D printing their end resources there. At GCSE, we use it to 3D print our NEAs, we use it in our A-level NEAs, we use it in our extracurricular projects such as the BIEA STEM Challenge, the Shell Challenge with Vex Robotics. And as well as that, we also have a 3D printing club here in school where students can just come in and freewheel, design whatever it is that they want on CAD, collaborate with some more expert students in terms of CAD and 3D printing in the 6th form, and then they just send us the file online, and one of either our technology assistant or one of the teachers will 3D print it and send it out.
Fantastic. We've also got one other question from Stephen of what's the next new technology that you'd like to bring into DT departments?
I think talking with my own DT department, I would love to get AI in our robotics. There's been a new release of an AI-based competition in robotics. I'd love to have something like that involved. I'd love to get a bit of STL or resin printing so that we can get more accurate and more technically complex printing in. I'd love to get really strong 3D scanning made available to schools. So that we can, for instance, iteratively model with modeling materials such as plaster Paris or blue foam, transform that into CAD, and then that is an editable free form, and then it can be transformed back into something which can be 3D printed. Yeah, and I actually think that really in terms of educational technology, the most recent, obviously the situation that's going on now has been a huge challenge for teachers everywhere. But talking from my own perspective, I've seen the value in what some online resources can provide, whether that's with quick Zoom meetings. I'm discussing with my year 12 form at the moment in terms of their future prospects and careers, helping them out with their UCAS references and their UCAS personal statement. The ability to have a conversation online is really, really useful. But having said that, I still think that it will never take the place of face-to-face teaching. So I think that the real pace of development of online resources and teaching has been brilliant, and I think that there's going to be even more there in terms of sharing and collaboration. But all of my students say the same thing. They really miss being able to speak to someone, and they miss the kind of conversation which you can have in person. So whilst we're gaining an awful lot from the current situation and the resources that are out there, there is no substitute for the kind of classroom environment.
Fantastic. We've got one more from Mary of how many in the end did this project produce?
So in terms of DT departments, I'm not sure whether it's safer to say we stopped counting or we lost count, but 30th of April was our last count, and that was 356,000. So my estimate is well in excess of 500,000. If we were talking about 3D crowd, obviously the numbers are quite high as well. Again, I think I've lost count on that, but I believe it's in around the 175,000 mark. Looking at my own school in terms of logging our numbers, I think we were in excess of 6,000, or my own area, in excess of 6,000, my own school, in excess of 4,000 between those manufactured and cleaned when we took the role as a cleaning hub. So yeah, you have various metrics of measurement there. But I think really the most important one when we look at it now is that, people are saying that, you've given us the PPE that we need, and that we are now ready to respond to a second wave. We're not spinning up the whole process and falling behind the curve. We are certainly ahead of the curve if there were to be a second wave, or if there were to be a secondary need for these pieces of equipment. I think that's the most important metric really, is that supply can meet demand very easily now.
Great. Well, thanks very much, Michael. That's all the questions we've had today.
Okay.
Thank you for speaking.
Thank you, Sam. Okay. Bye, everyone.
So coming up next, we've got Anne talking about her scrap heap challenge experience, and that will be at 11:30. See you then. So next on 3D Crowd Talks, we've got Anne Scrimshaw, who's talking about her Scrap Heap Challenge experience. Yeah, take it away, Anne.
Thank you. Thank you very much. So there are some moments in your life when you have to pause a moment and go, exactly how did I get here? And one such moment was when I was stood at the top of a tank. It was a fish tank full of enormous 2-meter long eels. The tank was the size that you could comfortably fit a semi-detached 3-bedroom house into. It was enormous. And I couldn't quite work out how I got here. This was completely outside of my normal experience. And then out of the tank popped Robert Llewellyn in a full Victorian divers equipment helmet. And that was part of being on Scrap Heap Challenge. I was on 9 different episodes. And so a week later, I was on an entirely different tank, shooting rockets into the sky. It was quite a weird and bizarre experience. So what I'm going to talk about is how I actually ended up on such a program and what it was like being on it, and also what sort of things I learned from it, because it was a really exciting and quite technically challenging experience, and it sort of shaped me as a person. So hopefully most of you know what I'm talking about. It was, of course, a program that was put on Channel 4, and they still show it every now and again. I suspect they've stopped showing it now because it was a very long time ago that we actually recorded the first episode. Now, some of you may have remembered the first episode. It was how to build a hovercraft. So the aim was to build a hovercraft in one day. We had basically from dawn to, the original concept was you had from dawn to dusk. And the pilot that was actually with 5, a team of 5 on each side, and you had to build this hovercraft on a scrap heap and then test it at the end of the day to see who would win. And this is how I got involved, because I was the expert on the pilot episode. I had at that time been racing hovercraft for about 10 years or more. It was 1997, so it was an enormous long time ago. Obviously, I was only 12 or something. No, I was 26 at the time, so still quite young. But by that time, as I say, I'd been racing hovercraft and building hovercraft, so could quite happily rebuild an engine in a field or do some glass fibering. Not a problem. I had a degree in automotive engineering, so I kind of knew a bit about stuff. But Scrap Heap took things to another level. The first episode, the pilot, quite honestly was quite poor. It was quite rubbish. It was sort of a Mad Max-esque theme. Later on, of course, they went all fine. But they didn't really know what they were doing. The production company was a very small production company now. They're one of the biggest in the world, partly due to the success of Scrap Heap. And so we'll sort of gloss over that episode a bit. But at the end of it, it was a really tough day. But at the end of it, I sort of thought, I know I can do better than this. And so when they phoned me up saying, would you like to be the team captain on the first series? I was quite keen to do this. The first series, there were just 2 teams of 4. We had a different expert every week. But I was on one team, and I had Bowser and Shen as my teammates. We were put together. We didn't know each other beforehand. And then Dick Strawbridge was the team captain on the other team. And I think this is the first time he'd actually been on TV. And I remember when we went into film that first episode of the first series, there were 6 programs. And I was walking through the scrap heap, which, back scene, which was very salubrious. It was a scrap heap and there were porter cabins everywhere. And so she indicated into the costume porter cabin. where Dick Strawbridge was there, but he was just getting changed. So he was standing there with his trousers round his ankles, and the producer said to me, "And this here is Major Dick," because of course he was in the army. So I had this vision of Dick Strawbridge with his trousers round the ankle. And go, "Oh, hello, Major Dick. Good to meet you." So then, of course, we had to build what they say you're going to build. Now, in those days, we literally only had one day for most of the builds. You can tell which ones we had to build in a day because the testing is all done at night, because we'd always sort of overrun. It was supposed to finish at dusk. In reality, quite often we overran, and the darker it gets, the later you can tell that we overran. And so quite a few of them were filmed, but like I say, by the testing was getting very late in the night. And in fact, I think the tractor pullers, we finished about 4 o'clock in the morning. And so it was a real sort of test. You'd start in the morning, and the first thing you would do, it would be about 10ish or something like that. They'd take your watches off, so you would never know what time it was. And the first thing you had to do was the only real, what I call true filming in the whole thing, which is where you'd have to walk through the scrap heap. We'd, at that point, have only just met the expert. We had no idea what we were going to build that day. And they'd tell us to walk through the scrap heap, and we'd have to walk through the scrap heap about 14 times. Because, of course, they wanted the wide shot. And then they wanted a close-up shot. And, oh, actually, could we have a shot now of you walking through the puddles? We'd like some close-up shots of your feet, please. And so we'd do all of this. And meanwhile, the assistant director was shouting at us, "Remember, it's war! Look tough!" And so we'd been walking through the scrapyard, trying to look tough. And then Bowser would be there going, because we hadn't been on the scrap heap for, a few days, and there'd be different things. And he'd go, "Oh, I think we're doing something watery this week, because there's lots of sort of waterproofing." Or, on the week of the tractor pullers, he goes, "It's something big," because we could see there was a whole lot more sort of bigger stuff on the scrap heap. And the way it would work is, obviously the expert knew what we were building, and the expert would have been discussing, for weeks and maybe even months beforehand what we were going to build. And so they'd have written basically a shopping list and given it to the production company and go, "This is what I need." Because, you'd never find a whole crashed microlight that you can build a hovercraft from on a normal scrap heap. And also, they'd have to make sure that the engines worked. And so they would buy, an old scrap Sierra or something when we did the tractor pullers, and they would have had to have tested them and made sure that they worked. And then they were put on the scrap heap. We'd still have to go and find them. I mean, sometimes we could never find the bits. That last one tractor wheel for the tractor puller was hidden somewhere underneath the skip. And we were looking for hours for that until someone from the production crew went, "Why don't you look in that skip over there?" On occasion, we even had to do the few negotiating with the other team. I don't suppose you need all of those wheels that you've got there. And so there was a bit of a plan, but it was essentially a scrap heap. And sometimes, you would find all sorts of different things. Over the different episodes, obviously the first 6 episodes that we did for the first series were all on the same scrap heap, but I did a few other episodes later and they were on different scrap heaps, and gradually things got better. We had to work initially, the ground was very rough, it was very difficult. Say you're making something with a chassis, you want everything to be level, and if you're on rough ground and outside and it starts tipping down with rain, it's like, oh dear me. But there were some good things being on the scrap heap as well. I mean, one of the amazing things was all the DeWalt tools. We had one guy who came from DeWalt, and he would just unpack like all the tools and put them on the tool rack. And we would just start drooling, going, oh, look at all these lovely DeWalt tools. These are, you know, we had the whole range. So it was amazing. I haven't many times got recognised after Scrapy. Occasionally, there's a bit of a niche market. But one time, a few years later, I walked into the DeWalt engineering office at their factory. I was working as a bearing application engineer at the time. And so I'd walked in there with a sales engineer. And it was a strange feeling walking in there, because I'd walked in many engineering offices. But what happened when I walked in there that time was there was this sort of murmur that sort of evaporated out around the office, because obviously they'd been watching carefully because all of their tools were there. And they'd even, I think it was linked with Black & Decker, so I think they'd even put in a team as well. And I'd never quite gotten such a response as walking in their office, which was quite weird. But some of the builds were amazing. We started off the first series building off-road vehicles. Again, I think we were still finding our feet, because, as I say, they'd put me in a team with these two guys. And what you probably can't tell from the TV was just how tall they were. Bowser was ex-army and was in the diplomatic police, so he could carry a gun. And he was well over 6 foot, so he was an imposing person. And Shen was also over 6 foot. I was wearing platform heels, so I didn't look quite so short, but they were enormous blokes. And they'd been given this 26-year-old to tell them what to do. And so it was quite interesting from a team dynamics on whether they were actually going to do what I said. But our side tended to work very much as a democracy. And you can see that on some of the episodes. Whereas Dick's team, he was an army major and he told them what they were doing. And so there was this interesting group dynamics. And every morning when we were told what we were going to do, we'd all go, oh my God, we've got to build this. And part of that was for the TV cameras, but part of it was also that enormous like, oh my God, how am I going to build a tractor puller or a medieval catapult? And I have no idea how to build a rocket or a pneumatic walking machine. What are we going to do? And so I remember I'd have sort of butterflies in my stomach, absolute terrible stomach pain. And they'd tell us what they were going to do. And the first thing that would happen was the two guys would go off on the quad bike into the scrap heap. And I'd be left there with the expert, who, like I say, we'd only just met. And he'd be going, right, come on, we've got to do this. And I would go, no, let's just sit here for 5 minutes. This is the only time today you're going to get 5 minutes to sit down and relax. Now I would try and take a deep breath and stop the butterflies from overwhelming me. It was good to have a moment of pause. When we're in the middle of chaos and we're in the middle of a project and we don't quite know what's going to happen, it's very easy for us just to run around looking busy. But if there's one thing that I learned on Scrap Heap, that was the builds that we built best were the ones where we all knew where we were going. And so sometimes taking 5 minutes just to stop and think and go, where are we going, was really important. So the ones where we didn't really know where we were going, like the pneumatic walking machine, I don't think any of us in the team, except the expert, had ever worked with pneumatics. We didn't quite understand how this walking machine was going to work. And so that was probably one of our longest, most difficult builds. Whereas the tractor puller, the tractor puller was wonderful. I mean, in many ways, it was quite a big build. We had a V6 Rover engine, so it was an enormous, sort of powerful machine. But within the first hour, we'd found the engine. Our expert was amazing. He built his first tractor puller in about 8 days, and so he was a sort of expert you wanted on your team. And we'd managed to support it off an engine hoist. And so within the first hour, we'd got the engine running. We'd found a front axle and just placed that in front of the engine. And we kind of looked at each other and went, we're nearly there. Not that much more to do. And that vision of where we were going really drove that project forward. We understood where we were going. But one of the other things that I also learned there was that sometimes you've got this project and it's like an enormous bowl of spaghetti, and somehow you've got to sort your bowl of spaghetti out, and there's all these threads and you just don't know where you're going to start. And so part of doing something like a big project like that was sometimes A, you have to know where you're going, but B, sometimes you have to then step away from that and go, yes, but what's the first thing I need to do, and concentrate on that one thing and not worry about the rest of it. You know where the rest of it's going to go, but it's doing that one thing and concentrating on that one thing. And sometimes it was the only thing that sort of stopped you just running around in a headless chicken type way. It's going, well, I know how to do this one thing, and then I know how to do the next one thing, and the third. And hopefully, by the end of it, you've managed to break this enormous sort of project down into individual parts. And when you're working as a team, it's quite good. You do the bits you know. Someone has also done the bits that they knew, which hopefully wasn't the same as you knew. And eventually it all comes together. And that's basically how we sort of tackled it. But some of the projects were really, like I say, quite scary projects. I remember when we did the speedboats, the expert, no, it was the judge, afterwards said to me, why did you not go faster on the test? Why on earth? He was really quite capable. And he was right. The boat was more capable than I did it. However, I'd never driven a boat before. I'd never had a practice to drive that boat before, because the crew was so worried that everything would fall apart because everything was cobbled together. We used to weld the drive shafts onto the ends of the engine. And of course, this would fry all the electrics. We lived and we learned. And so on this speedboat, the prop shaft had been welded on, but it was a 2 or 3 meter long prop shaft, and it hadn't been welded on straight. And the only thing between me and the prop shaft was an aluminium ladder, and I could see this prop shaft starting to wobble all over the place. And as I say, I worked as an engineer. I knew we weren't supposed to run shafts when they're above their vibrating speed. This was a dangerous thing to do. And so it was all very well the expert, who was standing safely on a cliff high up, going, why didn't you go faster? But he wasn't sitting on top of a vibrating prop shaft, having never driven a boat before, which didn't steer very well. It was, of course, only later, many years later, that I found out that actually if I'd have gone faster, the boat would have steered better. But of course, the boat didn't have brakes either. And it's all very well when it's not you on top of that prop shaft. For the tractor puller, they said originally it was going to be me driving the tractor puller. And Bowser and everyone else seemed quite happy about this. This will be fine, no problem. Yeah, you carry on, Anne. Yeah, no problem. And then they said, well, no, actually, maybe we'll get Dave and Bowser to drive them, you know, because we had the captain driving the other day. But we'll have the next, you know, second in command doing it. And so once he found that out, Bowser started welding in more patches, sort of just below his seat. And I said to him, it was fine. It was perfectly safe when I was going to drive it. But now you're driving it. You want these extra bits. And so I think it's very easy to say, oh, it's fine. But when it's your what's on the line, then suddenly, yeah. And so I suspect, really, one of the things that possibly was that they had to bring in is that they realised they needed a lot more health and safety. And so, although we did a lot of our tests on the same day, later on I was the judge in the 5th series, which was again hovercraft. And so what they had then was they had a build day, and then they had a test. They had what they call it, a safety day, and then they had a test day. So it was spread over 3 days. But this safety day, essentially, it was a day to make sure that the machines were safe, and they'd add in things like safety cutouts and things like that. But really, it was also a day where they could finish things off. And so I feel later on they had a bit more. It wasn't quite as sort of, you know, we really had to do it in one day, and that really, it made me realise just how much more we are capable of. Is that when you're put in a situation where you have to do something, and everyone's watching, oh, and we're going to film it so the nation can see, is that when you step up to the plate and have to do something, is that sometimes you realise you're capable of far, far more than you ever thought possible. And I think that's one of the key things that I learned from Scrap It Challenge. So many things, many things that I learned. But hopefully, you've also learnt a few things today. So anyway, I shall hand you back over to Sam.
Okay, well, thanks very much, Anne. So we've got a question from Lewis. What was your favourite episode?
I quite enjoyed the rockets. We had to build these rockets, and then we went and tested it. We had to stand on, you know, tanks in a tank place, you know, while we were at war thing. But also the catapults one, the medieval catapults, was amazing, and that's probably the one episode that has inspired many people. For example, you know, before that episode, they hadn't built the one at Warwick Castle, and they hadn't done, you know, like they did that enormous one, didn't they, that threw cars and things. So I think that was also quite an amazing episode. We just saw Dick Strawbridge's, you know, one sort of appear over the top of the wall, and we just went, my God, it's like a dinosaur or something like that has appeared. So that was also quite fun to do as well.
Oh, sounds great. So I've got one other question from Brad about what is your involvement with 3D Crowd?
Yeah, so good question. So what I do now is I run a Fab Lab. So hopefully you understand what Fab Lab is. It's a place where people can come and make things. And so we have lots of equipment like 3D printers, laser cutters, CNC machines and things. So my job is to show people how to make things, which, you know, links in nicely with having done all the Scrap Heap things. So I get loads of people walking in the door and go, I want to make something mad. And I go, yeah, sure, no problem. You know, compared to a medieval catapult, this is no problem. And so when we heard about doing the visors, I off work, well, I'm working from home at the moment, which is not really that much working, but anyway. So I went and rescued the 3D printers, pulled them back here, and I basically set up, we got about 3 or 4 3D printers that I've managed to set up, and I've been printing the visors.
Fantastic. Well, that's all the questions we've got. So thank you very much, Anne. It was a really interesting talk.
Thank you.
Thanks.
Bye.
So, coming up next on the talks, we've got the admin team. If you've got any questions for them, then ask them in the comments below, and we can get on to them. We should have Andrew joining us, and hopefully Gabby and Tim. See you then. So our next session today is with the admins. We've got Andrew, Gabby and Tim who are going to take your questions. So if you'd like to introduce yourselves, should we start with Andrew?
Hello, I'm Andrew. I'm obviously one of the admins. My background is actually film producing, nothing to do with 3D printing. And I got into this right at the beginning. Pass you on to Tim.
Hi, I'm Tim. Again, one of the admin team. Been in the team since probably the sort of first week. I think I got a call just the day I went into lockdown, saying, "Would you like to get involved in a project to produce 3D shields?" And it then swallowed me up. And it's been a really exciting ride. But my day job is not 3D printing or software development. It's I run a prop making business, but I've mainly been involved in 3D Crowd, creating an app to run the sort of logistics and the sort of information at the back end. So that's how I sort of joined.
Okay, I guess that's over to me. So, Gabby Howson. I am by day a IT project program manager for a consultancy. So something not related to 3D printing.
First week, I think I got a call just.
And my other half got involved in the 3D printing through a friend of mine. And that friend ended up looping me in. So I think I joined probably week 2, something like that, to start talking to everyone initially in London. And then I ended up helping out in the admin team as well. And it's been a bit of a roller coaster since then, but we've done fantastic things, I think.
Great. So we're going to take some questions from people who are watching. So we've got our first one from Alex of what's next for 3D Crowd?
Oh, it's an interesting question, that one, and it's one we've been rolling around in the admin team for a while, and ultimately we've decided it's not up to us. It's kind of the long and short of it. What we're planning to do is re-platform in time. But the important thing is we're going to keep the community together, and those that want to be part of a future, whatever shape that might be, we're encouraging to sort of join us and help shape that next chapter. So the options are, a myriad options of what things we might do. But one of the most important things that we need to do first is to stay in touch. So we're approaching all of the people who've signed up thus far to say, well done, and would you like to continue your journey with 3D Crowd? And if so, come join the future and help shape it. But there are some ideas. Come on, Andrew. What are some of the ideas that we've come up with for things to do? But it is, as I say, it is not up to us.
It's basically in various different stages. As Tim says, the important thing is actually, if we're going to continue, we need to continue as a community. So for the moment, we'll continue on Slack, but we might end up having to move on to something else. But that's just the way of keeping in touch. As many of you know, 3D Crowd was, we did create a company very, very early on because we needed to in order to get CE marking and insurance and basically cover everybody else. That is like to continue. And we think, realistically, the thing that got people interested in this was PPE and helping other people. Now realistically, PPE isn't going to be needed for very much longer, but helping people is. So we're thinking projects like the prosthetics that was talked about earlier. Have a very good talk on that, but there's other things that are similar. Someone's talked about seeding coral reefs with 3D printed parts, which is interesting because you automatically think plastic and ocean's bad news, but obviously if you're printing in PLA, it is degradable, and if it helps the coral reefs, they're great. There's other suggestions like robots that if we work with other charities like Oxfam or Save the Children or other ones, where there might have been an earthquake, we can sort of use little robots to search the rubble that are fairly cheap and expendable compared to the sort of £100,000 robots that keep on getting sent over. where they kind of send one or two over. We could send an army of small little ones that could be programmed with Arduinos and things like that. And then there's the educational side. There's groups out there, but obviously we're 6,000 strong, or 8,000 strong, 3,000 strong, depending on which number you listen to. And then going beyond that, obviously we're going to need funding to do this. And there's various different ways. One of them is just looking at obtaining funding grants from various different people. Things like Zuckerberg or the Bill and Melinda Gates Foundation, or any sort of government grants for sort of doing this, especially considering the kind of disruptive technology. No one really considered that distributed manufacturing was viable before this. So we can look at that, or we can look at a sort of commercial source of funding, where we find people who want 50 to 500 units of something in plastic, and we utilize that interest to take the project on, make a small amount of money for the individual makers who are making those, and then the company will take a cut and use that to finance its ongoing projects and its running costs. So yeah, there's a bunch of things, but the biggest thing you need is help from you guys.
Gabby, were there other thoughts around sort of education outreach and stuff like that?
Yeah, definitely. I think the talk from Michael Noonan earlier around the work that we've already been doing with the sort of education community and in particular all of these technology areas within schools has been phenomenal, and that's definitely something that everyone is keen on continuing within the community. I think the community spirit behind all of this has been so giving and considerate of all of the types of causes that Andrew's been mentioning, but equally desperately wants to also help people understand how they can contribute and give them some information on what these machines are, what they can do, how you can utilize them. We've had so many new members joining, and so many people have gone and purchased their very first 3D printer and been sitting there trying to work out, what does this part do, and how do I connect the nozzle up, and how do I heat, and equally having problems. And the amazing community spirit that's been there to help people get up to speed. There is sort of no ego in any of this. Everyone is so warm and open and welcoming, and the education on an individual level to help you as a new printer, and then also looking at doing talks like this and outreach into schools and outreaches into other educational programs is something that from my contact with the community, people are really keen on continuing with. So we would love to work with everybody out there who's listening to this, everyone in the community, anyone else who's interested in joining in continuing and rolling this community out and keeping it together.
I think what you mentioned there about just briefly touching on the fact that people went out and bought 3D printers, that really shocked me as it developed. It became clear that, so as people signed up, and we asked the question, what would you like to be able to do? Well, how can you help? And there were lots of people, and we were able to see this sort of list of people, and some people coming up, I've got engineering background, I've got 20 3D printers, I've got experience with logistics, all this sort of stuff. And there are other people coming and going, I'm going to buy a 3D printer, and I'm going to join you, and I'm going to help. And that really shocked me. I just assumed that it would be people who were already, genned up on the tech. But actually, no, there were loads of people out there who thought, I can actually help on this, and I'm sitting at home, and I'm scared, and I want to be able to do something to help this country and to help the people in my neighborhood. And that was really amazing. And then the rest of the community helped when they shouted, oh God, I don't know how to even build the thing. And people really reached out and helped one another. I think the community's been amazing over the last couple of months.
That's definitely the case. I mean, it's amazing the fact that actually this is the first thing I've come across where you could ring up anybody from your phone book, even if you haven't spoken to them in 20 years, and go, I need some help with this. And they just responded, yeah, okay, fine, all right. What do you need and when? Yeah, I mean, it's one of the sort of the best moments for me was about 2 or 3 weeks in, when we'd just finished organising the big print, and we realised we've got about 6,000 units still sitting up in Sunderland. And it was the Thursday night before the bank holiday, and we were like, well, how do we do it? And we literally put out a sort of, okay, fine, on the general channel on Slack. We need some help. And within about 3 minutes, we had about 40 people on a Zoom call discussing how to get these 6,000 units from one end of the country to another. And that you just don't find anywhere else in just the sort of speed to be able to organise that. It's amazing.
I think that takes us really nicely onto our next question, actually, which is, what is your proudest moment with 3D Crowd? From Owen.
I would definitely say, yeah, it was that call at, say, 10 o'clock at night, being able to sort of extract 30 or 60 people just on a call, and then being able to organise it, over the course of half an hour with literally nothing else than, we have 6,000 units here and we need to get them to these 40 sites. And by the morning, that truck was travelling down the country with a bunch of people coming to spider into it and spider out to it to get them out. That's my one, I think.
Tim or Gabby, do you have a personal favourite?
Go, Gabby.
Okay, me, I think probably sort of about 3, maybe 4 weeks in, after all of that initial chaos of the big print going out and trying to get different regions set up, I think we had one particular Zoom call where there were 13 regions represented, with regional coordinators. A number of area coordinators and hub coordinators were there for each region as well. We had someone from procurement on talking about what we were doing with Visor procurement and elastic procurement. We had Adam talking to us about the social media piece, and we were just starting to do launch the website revamp. We had each of the regions sitting there and talking about all of the different hubs that they had running. And suddenly that realization of, hang on a second, we have created an organization here from absolutely and utterly nothing to a working, functioning group of amazing people with all of these expert skills, all working together in general harmony towards this amazing goal of getting out as many face shields as we possibly could. And each of the regions all really supporting each other, coming up with ideas, being and this really neighbourly, wonderful tips and tricks that were coming out constantly. And I had that split-second moment where I could sit back, instead of me answering questions, other people were pitching in and going, actually, I know how to do that, I can help with. And suddenly this community was formed, and people were finding their place. And we've had lots of change since then. We had lots of change before that, but I think that moment where I could see that everything, all the pieces kind of clicking into the jigsaw was amazing. Tim?
I'm not sure I can think of a specific moment, but I do. But it was because I got involved and started putting together this app. So I'm not a software developer, but I do use a piece of software called AppSheet, which is available online, and I use it in my business, and I've used it sort of streamlining bits of my business. And when I saw what was beginning to grow in 3D Crowd in the first few days, so it was a few spreadsheets that various people were setting up, and it was orders coming in from various places. There were people trying to volunteer and sign up. And I realised actually we had a sort of we were going to have a data issue, which was going to need handling quite quickly. And I thought actually I might be able to build an app which will help sort of streamline this. And I sort of sat there, and it nearly drove me insane, because it was testing my powers to their absolute maximum, and beyond. And I thought I don't think I'm going to be able to get. I've now committed 3D. I've promised the rest of the admin, who I have never met before, I'd never met any of these people. None of us had ever met before this began. And I promised these people it was going to work, and I was going to do it. And I think I can figure this out. And I realised we were sort of committed. And there came a point about 3 weeks in where suddenly there were lots of regional coordinators signing up, and the number of people engaging with AppSheet was suddenly skyrocketing. Gabby was in touch about sort of 10 times a day, going, "Oh, can you add another 5 people?" And I was thinking, "Oh my, holy mackerel! This is really going to test me and AppSheet, and everybody's going to realise that it's not up to scratch." But I started to see the little pins for all of the orders turning from red to orange to green. And I realised actually all over the country, despite the fact it was a far from perfect piece of software, the volunteers and the coordinators and everybody had gone, "Okay, this is how we're going to do it. This is what we've got, and we're going to engage with this." And that the orders were being ticked off and things were being delivered, and that this piece of software was helping. But it was the way, again, it was that moment where I realised that everybody was engaging with it, and it was all beginning to happen. And you could see it happening on the map. The map was just sort of the map of the UK, which was covered in red pins of thousands of people wanting face shields. And over the course of the next couple of weeks, it all started to turn green because the orders were being fulfilled. And that was lovely to watch. It was amazing. It was actually happening out there. Brilliant.
The coordinators had some favourite sayings. They did talk about turning the map green. That was a big push for them, and turning volunteers purple, because every single time that someone who was one of the makers producing frames and printing them did a stock update, it would turn their little symbol, their little pin on the map, purple. So some of the regions, even within the areas in the region, are having little competitions of, how quickly can they turn everything purple. There was a lot of gamification that was going on, and it worked really, really well.
Oh, that's great. I think it's worth saying that though we are, we gaily call ourselves the admin team, we are just another group of people who volunteered and signed up, just like everybody did. And we didn't know one another before this. We have, most of us have never met. We've met via Zoom calls repeatedly, hundreds of them. But that's it. But we this whole thing has come together from people who have never met one another and may never meet. It'd be lovely if we can all somehow get together at some point in the future and all raise a toast to what we all achieved.
I think that's really inspiring to hear. So we've got one more question from Christine about how many active members there are currently.
Ooh, that's a good one.
Who's gonna race for AppSheet first?
We got, about 7,500 people signed on to Slack, but we know they're not active members. When we send out the MailChimps, we know about half of them open up. And we think we reckon about 3,000 people are engaged on at least some level. And obviously that will depend on what we're doing. The really active members, we're talking about 1,200, and they're people who are really actually actively doing something every couple of days. But I think 3,000 people going forward is a reasonable assessment of how many people we think are actually involved and actually interested in keeping going.
Yeah, I think one of the things that's worth noting is it's actually quite difficult for us to get accurate stats on this. We can kind of go finger in the air at the sort of 8,500 that are signed up on AppSheet. So through the volunteer sheet that people sign in through in the first place. Not everyone makes their way through to the delights of Slack, in inverted commas. But on Slack, I think that a lot of groups initially started on Slack. A lot of people have joined, but then what we're finding is that if people are sort of delivery drivers or doing who are makers, They might very, very occasionally join into Slack. Very often they're just doing a dispatch form through a Google form, not signing into Slack. And there are lots of WhatsApp groups that have spun up, or, you know, little pockets of people. People have been finding out that they're printing and their neighbour but one is also printing. As you know, there's been some really amazing communities gathering together. And I'm very aware that in lots of those communities and pockets, people aren't active on Slack. So the Slack active numbers have dropped, but the numbers outside of Slack continue. So yeah, as I said, it's very much a guesstimate from a perspective in terms of how many people are still actively doing things. It's a minimum of I think it was 2,000 active people on Slack, but then add in other people who aren't or are avoiding Slack. There's probably at least another 1,000 or two on there.
It's actually, speaking of that, it's actually quite important that the email went out today, or the first of the series of emails went out today. We really need people to sign up again. So that we can actually, as much as anything else, retain data and stuff like this. Because obviously when we started, we were 20 people. We weren't really bothered about GDPR issues because everybody was expected to know each other. And then, you know, we grew exponentially very, very quickly. So we have to make sure our systems are in place, unfortunately. And that means that to make sure that we know, actually part of the reason is to make sure we have an idea for numbers going forward, is we want people to fill in that form. And then not so much sign up again, but actually reconfirm, so that we don't keep on bombarding you with emails if you're not interested, or equally well, bombarding you with emails if you are interested.
Great. Well, that's all the questions we've had today. So thanks very much, guys, for joining us. It was really interesting to hear.
Thanks to everybody out there. Thank you.
Bye.
Thanks, guys.
you've been hearing all day. So I'm going to talk us through how 3D Crowd actually make a face shield. This is mostly for people who don't know about 3D Crowd and what we're actually producing. It's going to go from start to finish and how the process works. So the main thing involved is people.
we've had about 8,000 people involved, and many more driving, helping clean, and do other things. So yeah, we'll talk about that. So a little about who I am. In sort of normal life, I'm a video engineer. I work on sort of live events and theatre, and also program video. So here's a project I did last year in the United States for the 50th anniversary of the Apollo mission. And this was a company called 59 Productions. This is what I work on generally, so projection and LED screens. It's probably one of the biggest events I did last year. And here you can see we're working, and so mainly what I do is sort of sequence videos and make sure they work to time with the show, and work with the designer for how the show is meant to look. So first of all, we're going to talk about the design of the shield. So these were made by Joseph Prusa, who runs a company in the Czech Republic. They started in 2012, creating printers. So the design is open source for their printers and for the face shield. They've now grown to nearly 200 people, and they sell about 6,000 printers a month. This is their designer printer, and that's what they mainly set up to sell. So the face shield is called a Prusa RC3, and it's made of 4 main components that you can see here. So the 2 3D printed components are the orange ones, and they consist of a top band and a chin piece that helps to keep the shield in the right shape. Then we've got a piece of elastic that's used to secure it to people's heads around the back. And then there's a visor that attaches to the front on these points you can see around there. And so there were other designs for the face shields first. There's the RC1, which you can see has got more of a curve. And they changed that because they felt it was pinching on people's heads here, and it wasn't as comfortable to wear. So then the RC2, they opened that up, and they kept, you can't really see it in this picture, but there's holes around the forehead, and people were finding those uncomfortable. So they ended up with the RC3, which is what we've been making. So a few of the advantages of this are that they can be stacked when they're printed. So you can see here, it's a website called modsebly.me, and people have been using that to be able to create their STL files that they can then print. And that was sort of part of the original design, was making sure that one printer could print a handful of them without having to be checked on. So this is my printer, and here's one of the parts that I printed. It's a Lulzbot, and I've printed about 40 pieces now. So across the country, we've got 8,000 people printing. They vary from individuals, one printer like myself, to people who've got whole print farms of 20 or more printers, and they can churn out like up to 100 or so a day. And some of them have worked with their companies for sponsorship to help them buy materials and printers and try and expand that. So it all starts, once people have printed them, they get taken to their local hubs, and the local coordinators will help collect them. Quite often they're in people's houses, and they'll be collecting from up to a couple of hundred of people and getting all their prints together. They'll QC them and just check that there's no faults, and if there is, help feed that back to the maker on what they can improve. And we've got a lot of, in the community, people helping each other and sort of putting together ideas of how they can improve their prints, problems they might not have faced before that other people have, and sort of help each other that way. So then they'll get sent on, sometimes to a regional hub, where they'll get collected into bigger batches, and then they'll go into a cleaning hub. So this was one of my main contributions to 3D Crowd, was we were donated a space by a company called Neg, who have a rehearsal venue in Park Royal called LH2, and they donated the space for a month, and we were able to clean nearly 5,000 there. And each day we'd try and get up to 500 and work through those. So they'd come in, we'd separate them into batches of 50, separate them into the 2 materials. We had PLA and PETG and wash those up. So first they'd go into a tub of Milton. They'd sit in those for 15 minutes. Milton was partly chosen because it's very easy to get hold of. It's in pretty much every supermarket shelf and it's pretty cheap. So we leave those soak 15 minutes and then take them out and hang them up. There you can see I'm trying to organize them by color. It did become a bit of an OCD obsession. And then we'd leave them probably overnight and let them dry. We just had the chin pieces laid out. And then we'd also have, for the visor cleaning, which I haven't got any pictures of, we either soak them in Milton or IPA and then use a squeegee to make sure they're not too streaky. The Milton dries on them quite heavily and make sure people can see properly. And yeah, I learned a lot doing this. It's obviously not what I normally do, but we got a lot of friends in. There's probably 10 or 20 people who came to help. And it was, yeah, really impressive. Everyone who asked was willing to come along. Yeah, maybe just to get out of the house, but who knows? So then once they've been cleaned and dried, we'd bag them up. So we would bag them into 5s and we'd then box them up into bigger batches and we'd send them across to the other hub in North London and they'd put them into orders and send them out. One of the things we just did was left them for 72 hours to make sure there's definitely, do our best to make sure that there's nothing left in there. And that's why it's got the sealed date on. So then once they're at the hub, they'll look at the orders. So we're using a program called AppSheet that Tim, who was talking a minute ago, put together. And he made this program basically that collated all the orders and all the coordinators could look and see what orders were active and what we needed to fulfill. So we had a number of regional and local coordinators who'd call and try and find out how many people need and check they still need them, and then organize someone to deliver them. So across the country now, we've delivered over 185,000, and we're still going. Each day now, we're averaging about 800. And then within London alone, we've delivered 50,000. And that's cut up into different regions, bits of London. And so there's a lot of people who, even though they aren't printing, are helping phone orders, organize transport, and make sure stuff gets to where it's needed. And so a lot of our transport is delivery drivers who have volunteered, people in their cars who are just willing to help out. And there was some relays, as talked about earlier, that people would drive a section of a journey when it was a very long journey, and they'd all meet each other on motorways, in parks, to hand over the kit and manage to get things all the way across the country. And another one of our big things has been Bike Shed, who have really helped out with hundreds of deliveries. They're a volunteer group similar to us, who are just happy to deliver stuff on motorbikes. And they've set up a really nice way of being able to book it in an app, and it just happens. And it's been really useful. And then finally, they make it out to the people who need them. So here's a selection of pictures from across the country. And it really is incredible to see sort of all the different places they go to. Yeah, right the way from theatres, all the way to care homes, doctors' surgeries, where people can make sure they've got the protection they need. So we'll just see now if there's any questions. This isn't going to be quite as smooth because I've got to check it for myself. So we've got on about how and why I got into 3D printing. So myself and my partner Leo, we first got a MakerBot and didn't have a huge amount of success. It was maybe not quite what we'd hoped for. And then later on, we actually upgraded to a Lulzbot TAS 6, which has been great. and we've printed a lot for work. Some little project boxes, little bits for around home, and stuff like that. See if there's any others. I don't think there is. So our next talk is at 1:45, and that will be on 4D printing. We'll see you then.
Hi everyone. So next we've got Ellis, who will be presenting on 4D printing. Have you got any questions? Then put them in the comments and he'll answer them at the end. Over to you, Ellis.
So thank you very much, Sam. So hi, I'm here to talk about 4D printing and time-dependent 3D printing. I'm going to explain way more about these two words and these two phrases throughout this presentation. But firstly, I just want to give an overview of who I am. So I'm recently Dr. Ellis Marshall. I've just finished my PhD in 3D and 4D printing at the University of Hull. I've been in industry quite a bit. I'm members of a few chemical societies as well that I put on there as well. Me currently, I work at the Ore Innovation Centre, which is part of the University of Hull. And what this place is a low carbon innovation centre aimed to help us transition into a low carbon economy. This is based near Hull, so East Riding of Yorkshire, northeast, all the way up in the middle of England, basically. Yeah, so my role there is the technical manager of this workshop, of this place, and it's a fab job and it's a fab place to be. So I just want to say a quick thank you to 3D Crowd. So my role with 3D Crowd was, I was in the Yorkshire region, obviously. I was the coordinator at Hull. So in the Ore Innovation Centre, we were a Hull-based cleaning and distribution hub. And I just want to say thanks to all our volunteers as well that printed all these face guards for us and helped distribute them to any orders locally within Hull and York itself as well. So big thank you to all our volunteers that helped. We did 365 at least headbands in our region. We probably did more. But yeah, so a big thank you to everyone who helped. And a big thank you to everyone at 3D Crowd. You guys are awesome. So I just want to give everyone a flat base of what is 3D printing. So we're all on the same level, so we all know what it is. And then we'll move on to the more 4D printing aspects. So 3D printing, very simple, create a 3D object layer by layer, starting from the bottom and another layer on top. And then you keep going in successive layers until you get your object. So this works in the X-axis, the Y-axis, and the Z-axis. And it's a nice, easy process, and it's created all these wonderful headbands that the 3D Crowd have used. Who uses 3D printing as well? All these guys. So we've got NASA, they use 3D printing. Hasbro, so Sweets, Hershey's, they use 3D printing. Apple, Ford, car manufacturers. Architects use 3D printing. Surgeons use 3D printing. And you guys at home use 3D printing, which is just amazing. So everyone has a 3D printer nowadays, the big boys and you at home in your lounges playing with 3D printers. It's great. So 3D printing in general is 7 different technologies. They can all be used in different ways in different manufacturing industries. We're not going to go into this, but I just want to say there's 7 and they're all equally awesome and all equally have their advantages but also disadvantages as well. But I'm sure that'll be another talk for later on. So now we get on to the interesting topic, 4D printing. So 4D printing uses the 4th dimension. If you've watched a lot of Doctor Who, or you're a sci-fi nerd, or you just love physics and science, the 4th dimension is time. But how does time apply to 3D printing? That's always an interesting topic. I like to think of 4D printing as time-dependent 3D printing. So that probably doesn't help your head get around this anymore. So time-dependent 3D printing. 3D printing, so say 3D print a flat sheet, but it will continue with effects that continue beyond that print. Not with me yet? I'll keep going. So time-dependent 3D printing. So on the left, say it's midday, you've 3D printed a flat sheet of paper. You put it in a bath of water at 12:01. At 12:02, you take it out of the bath of water and it's changed shape. It's changed over time to another shape. So that is time-dependent 3D printing. So again, you can 3D print an object and it just sits there. But time-dependent 3D printing is you react it or you give it a stimulus and it changes shape or function even. So some examples. So time-dependent 3D printing can not only react with water, it can react with heat, light, current, so electrics, magnetism, and it can also be a chemical reaction, or a reaction to a chemical stimulus, so like acid or alkali. So on the right here, we've actually got some examples of time-dependent 3D printing. We've got a snowflake shape. You could quite easily see yourself 3D printing a snowflake shape quite easily. You stick it in a bath of water or you heat it up though, it does nothing. But if you 3D print with this time-dependent technique, it changes shape if you heat it up. So it goes into a flower shape rather than a snowflake shape. Are you still with me? I hope so. And it's also inspired by flowers, this whole technique is sort of very flower influenced. So again, we've got a flower at the top. You start out with a flat flower, and you give it some heat and it will curl up and curl up and curl up. And it will also, when the heat is taken away, it can retract back to its flat shape. How does time-dependent 3D printing occur? Well, you actually use a 3D printer, but you play around with the material inside. You use a different material than your traditional PLA or PETG or ABS. You use a different material. This is where I just want to do a sidestep into my research area. Like I said, my research was 3D and 4D printing. And this will hopefully explain a bit more about the 4D printing side. My research area was to tackle climate change, big topic. So in 2018, CO2 levels were 407, and today they're now 416 ppm. You can look at what tomorrow's are, yesterday's are on co2.earth. I would recommend you go there. But, so, my research area was 3D printing these little nanocrystals with a 3D printer to make 4D printed materials. So, what these 4D printed materials can do is they can react with CO2 or other pollutants and change and take them out of the water. Are you still with me? I hope so. So, time-dependent 3D printing, as a little summary, can react to heat, water, light, current, magnetism, and they can be affected by chemicals. Okay? Applications of 3D printing, though, or time-dependent 3D printing. So, who uses it? Currently, there's only about 4 major players in this 3D printing technology, or 4D printing technology. We've got Autodesk, NASA, so space, Adidas, shoes, and the 2 3D printing companies there. So, how do Adidas use 4D printing? This is their supposedly 4D printed reflective shoe. So what is 4D printed in here is they've 3D printed this midsole or this mesh area, and this mesh area reacts to pressure and it can expand and contract, just like a running shoe would. But the beauty of it is it's been 3D printed and it reacts to an external stimulus, which is your weight going on it. So you can call it 4D printed or time-dependent 3D printed. So another fabric or another material that's 4D printed or time-dependent 3D printed is NASA's space fabric. So they're looking to use this on in space, on ships, but it's a very reactive material, well, reflective material, I would say, and it looks like chainmail, and it works a bit like chainmail as well, and it can mold to a shape and stay in a shape, or it can change shape to a different stimulus. It's incredible material. I would really recommend looking up the NASA space fabric. So another area of 4D printing. So this is actually really cool. These are stents in arteries, and what they do is they react to the heat of the body and expand. So when you put them in the body, they're nice and small, they can fit down the vein quite nicely. When blood starts flowing and starts to heat up, it expands and you've got a stent in there, which is incredible technology. And I think there's a big future in the medical applications. On these medical applications as well, I just want to say the future is crazy, and it looks brilliant for 3D printing or 4D printing of organs or body parts. They've done 4D printed ears, hearts, lungs. So the picture in the middle here is a lung. There's blood going through it and there's oxygen coming in and out. On the right, I think that's a liver. A model has been 3D printed, and then it doesn't fully function yet, but it's on the way to functioning. This is incredible technology, and this is the future of 3D and 4D printing. You could replace your ear if it's come off. And the beauty of it is you can use your own skin grafts. There's no anti-rejection medication needed because it's your skin going back onto your body. So, a summary. Time-dependent 3D printing is 3D printing with effects that continue beyond the print. And these can react to water, heat, light, current, magnetism, or a chemical stimulus. It can be any one of those. Yeah. So thank you very much. I just want to have a quick little sort of a quick look here. So here is my recycling technique that I'm currently doing at the Your Innovation Centre. So a quick shout out. If you have recycled waste or any old PLA, used PETG parts, failed, whatever, and you want to reuse them or get them recycled rather than chuck them in the bin, I'd welcome them at my centre. And what we do is shred it down and make it into a new roll of filament for me to use for students or other applications. So we're trying to be green and low carbon by saving it going in the in your waste bin. So yeah, thank you very much. Thank you very much for your time. And if you want to get in touch, I'm on Twitter, I'm on LinkedIn, and I've got my email address here. So thank you to 3D Crowd, thanks to the University of Hull for me, and thanks to the Your Innovation Centre. So thank you very much. And any questions?
Great, thanks, Ellis. I'm sure there'll be lots of people who've got failed headbands to send to you. So we've got a question from Andrew of what is your particular speciality?
Yeah, so it's metal organic frameworks. So they're crystalline materials, and I've synthesized them and put them into plastics and 3D printed with them. So these can be used to degrade, well, I've done a paper and it's degrading nerve agents. So these can be placed into a solution and used to degrade pollutants to the atmosphere. Nerve agents are one. They can also be used to take up CO2. So they're carbon capture devices in a sense.
Great. We've had another one from Norv that's asking, how do you see your carbon-eating nanoparticles being used?
So I see them being used. So once they've been 3D printed, once they're in this shape, I see them being used in filters. So such as the large, gas masks filters. So they could be placed into that and taken out and reused, washed and placed back in. They could also be used in power station flue gases. So you could put them in there, take them out, wash them, put them back in. So they're reusable and recyclable, which is a major benefit. I like the 4D printed heart, I would say. That is very cool. But I have just read up on some heat reactive curtains. So they will open and close when it's hot or cold outside, which is a very strange application for 4D printing.
Great. Well, I think that's... Oh, we've got one more question that's just come in from Ian of, could your CO2 cleaning particles be used in the home?
Yep, don't see why not.
I guess, is there any particular applications maybe you've tried already that they might be useful for?
I mean, they could work alongside air fresheners. So a lot of these air fresheners have carbon filters in, which is just a sheet of carbon. And so what you could do is replace that carbon sheet with MyFilter, which would be reusable and washable. So you could take it out yourself, rinse it, put it back in. So it could be used alongside these air fresheners that have fans in that circulate the air around.
Great. Well, thanks very much for your time. Yeah,
Thank you.
and thanks for presenting. So we've got our next talk is at 2:30, which will be A Purposeful Life. So for our next talk, we've got Rob, who's going to be talking about his work with people. So hand over to you, Rob.
Thank you very much, Sam. Hello, everyone. Very nice to be here today and lovely to be part of something just so special, and really looking forward to talking with you for the next few minutes. So a little bit about me, I suppose, very short, is my background and experiences are really wrapped around developing and supporting people. That's really been the lifeblood of what I've been involved with for 30 plus years. And it was all born out really from a very special part of my life, growing up in Devon in the 1970s. A question that we used to ask a lot on many of our development programs was, who has had the greatest influence on your life? And this is really pertinent to me, but the greatest influence for me growing up as a very young child, from about the age particularly of 9, was my grandmother, Violet Sansom. My grandmother lived in this little house, which still exists today in Totnes, a little tiny house on the wall, as it was always called, in South Street in Totnes, if you know Totnes at all. And from the age of about 9 to my teenage years, I pretty much grew up in that house with my brother as well. The reason being is that my father had a breakdown when I was really young and suffered from very severe bipolar disorder, and that very much shaped a lot of what went on in our early lives, dealing with my dad's mental illness. And so we were really brought up by my grandparents, particularly my grandmother. And some of the things that I remember that I've been looking back fondly on over the last couple of years, because it really has helped shape my life, and you'll see the relevance of this as I go through my talk today, is how much my grandmother's influence, and I would describe it as leadership really, was the turning point for really helping to shape my life and help me out of a rut really, in terms of how I was as a very young child, very insecure, very nervous, very quiet. Used to hide myself away most of the time and really didn't feel that I had anything to say of any value to anybody, and so would tend not to speak. And my grandmother, over a period of years, would really patiently sit with me, ask me questions, encourage me, and basically I grew up in an environment where I felt like I was being listened to and supported in all of those things. And one of the things that I always remember very, very clearly, and my brother and I hold very dear to us, is that every week, without fail, when we did go back home briefly for periods of time, my grandmother would write to both of us separately a letter, post it, and we'd always receive a letter. It was quite a long letter, and it would be my gran recounting and describing the wonderful time that she'd had with us the previous week, and recalling all the things that had happened and all the really positive stuff, and how much she valued and loved us for who we were and what we brought to their lives. And you look back on those letters now and they're actually quite difficult to read. And a few years ago, I sat down and I reflected on what I'd actually learnt from my grandmother and how that had shaped my life. And there's lots of things, but to try and summarize it very simply, these are some of the key things that came out. What I realized very early on is that my grandmother saw my potential. I didn't see it. I didn't really know what I was going to do in my life. I really didn't see a direction or really a sense of what skills I had or what I could do really in the world. But she saw my potential, and over a number of years of nurturing me, I really began to discover my true self. So I always say that my grandmother found me, found the true me, buried somewhere within the insecure little child that I was for many years. One of the values that's really stuck with me, that I use a lot in my own work, working with other people, is authentic listening. And I describe it as that because it's that listening that's really patient, that somebody sits down with you and really gives you their full attention, and they're listening beyond the words. They're trying to understand what's behind that in terms of the person, what's going on with you. And that really struck a chord with me that's been very much part of my values and my approach with other people for the rest of my working life at least, but also with my family and friends. The other thing that my grandmother gave both my brother and I was space to play and learn. And I think that again is a very good lesson to learn about how we can develop in organizations, giving space to people to try things out, to get better at stuff by being brave enough to have a go. And sometimes we're put in situations where we're not given that permission to actually just play and learn. And that's one of the things that my gran really encouraged of us. It wasn't a word that I knew at the time, but coming back to it now, and it's such a big word that's discussed a lot thanks to the likes of Brené Brown and Daring Greatly. But vulnerability is okay. You know, to be able to say to people, actually, I'm not feeling okay today, or I'm not feeling confident about this, is actually a strength, is not a weakness. And it took many years for me to realize that. And again, it's something that is very much embedded in supporting other people, in understanding that vulnerability is not a bad thing. And the other thing that my grandmother did was ultimately for me is build a legacy of trust and appreciation, which was mutual. And again, for me, that's the fundamental pillar of working with other people, is that you've got to start from a position, particularly with people you don't know, of building a true relationship built on trust, so that people are open and honest with you, and you can continue to build on it for the future going forward, and to value what people do. So that appreciation and valuing, and telling people how much you value them and specifically why, which is what my grandmother was doing in those letters, is really powerful. Like I say, Brené Brown, I'm a great fan of, I think she's been very brave and powerful in the things that she said, has talked a lot about vulnerability over the last few years that has resonated with so many people. It's such a great quote. One of the things that fascinated me in later life, and I think it was born very much out about the way that you treat people and what you get from that. So if you treat people well, you get good stuff, and people will always go the extra mile. And if you treat people badly, there is no commitment there. You know, they may do it under a compliance-based approach, but you won't get loyalty and you won't get people going the extra mile for you. So one of the things that grabbed me very early on, and I'm sure a lot of people on the call today will be very familiar with Daniel Pink's work around drive. But when he looked at a lot of organizations in terms of the things that people really valued and motivated them, it boiled down to these three things: autonomy, mastery, and purpose. And I keep coming back to this because part of the work that we've been doing over the last few years is very much built around how can you create a culture where these things can thrive and grow. You know, you need to give people permission, and people need to feel comfortable that they can go off and make decisions for themselves and own things, because you get so much better quality work out of people. And again, like my grandmother, giving you space to play and learn is very much how we get better at stuff. You know, we have to do before we reflect, and then we realize, you know, the things that we could improve. And then finally, purpose. I think purpose is such a driver, and it links so much to the whole project with 3D Crowd, which I'll talk about in a minute, because we need meaning in our life. We need something to get up for in the morning. And we have a very strong urge to contribute and add value to the world and to other people. I think that's really, really important. So a few years ago, through a series of eventful moments, which I haven't got time to go into here, I met a guy called Kevin Miller, and Kevin and I started conversing about our own experiences of working in different organizations, some good, some bad, and ultimately the impact it had had on us personally. And we found a lot of parallels in our lives, even though we're different ages, in terms of the experiences that we had. So we started a very long journey. It took over a year of lots of coffee break conversations, talking about, we really felt very driven to want to do something and make a small dent in the world with, you know, our own thoughts and ideas about this, but also to find out what other people were doing as well. So we created a movement called Humanizing Workplaces. which was our starting point for all of this. And we have an anthem quote again from Brené Brown, which really kind of sums up what we're trying to do. And that is to really talk about culture in terms of how do we create environments where people bring their authentic selves to work, their whole selves to work. And you can only do that when you create an environment or a culture in which people feel safe, they're seen and heard and respected. I think that kind of just sums it up so beautifully. And sorry, I haven't got this photograph there. And one of the things that we started with was very much, where do you start? So one of the questions that we were asked a lot was, you know, okay, we want to do some culture change in our organization. Where do we really go with all of this? And we've discovered that actually the best place that you can start is by listening to the people in your organization. So we created, through the help of work with Barry Waymiller, which I'll talk about in a minute, something called Listening Plus sessions, which have a structure, but only have a structure to ensure that they're set up for success. And they ultimately are about getting a voice and hearing back from every single person in an organization to really get a sense, a very clear sense of what the culture is like in that organization, all the good, all the bad, all the bits in between. And what comes out of that is what we call a health report. And that could be an organizational health report or a team health report. And that report helps you to determine 3 key things, and that is looking for quick fixes or quick wins in your organization, small things you could change today that would really make a difference, short-term projects, and long-term change opportunities. That's the kind of things that start to fall out of those Listening Plus sessions. One of the interesting byproducts of that is it starts, in some organizations we've done it in, to start to build a new sense of conversation. So there's conversations right across the organization, and we've encouraged organizations to share many more stories within their organization. So, you know, at manager level, at operator level, sharing stories that connect people with the organization, connect people with each other is really, really powerful. One of the sort of standing stones that we built Humanizing Workplaces on is thanks to the work of a wonderful guy that you may or may not have come across called Bob Chapman, CEO of Barry Waymiller. They were the ones that started listening sessions with all of their staff when they went through some major culture change in the late 90s, early 2000s. Bob charts the story of the culture change of Barry Waymiller through Everybody Matters, a wonderful book that really kind of encapsulates what they did. None of it is rocket science, but the difference with Bob is they did it, they made it happen, and the impact of culture change right across a global organization, it's a very big organization, has been absolutely staggering. And Bob actually is a real voice at the moment in the current COVID-19 crisis, really sharing an awful lot of support for other organizations in how you get through this by not sacrificing your staff, but looking after your staff all the way through. And I recommend Googling Bob to see one of the TED Talks he's done, or actually to buy the book and read the book yourself. Some of the things that Bob quotes, and we use it a lot in Humanizing Workplaces, a reference to Bob, is Bob's realization that you move away from seeing people as employees, job descriptions, just your staff, and actually seeing them as someone's precious child. Because he said, if you see them like that, once you've seen that, you don't unsee it. It's that thing of care. If you see them as someone else's precious child, then you're much more likely to care about them and actually look after them properly. The other thing that Bob talks about, and it's really a mantra in the organization, is we measure success by the way we touch the lives of people. That's their KPI, if you like, which is a really powerful one to think about. Oh, sorry. And the final one is leadership is the stewardship of the lives entrusted to you. That huge responsibility of being a leader and looking after people is so much greater than so many organizations tend to treat it as. And you can learn a lot of lessons from Bob Chapman and Barry Waymiller through that. We had the real privilege of going on a visit to a Barry Waymiller factory in Nottingham a couple of years ago. And on the visit, we met this guy, and he was a prime example of how culture change makes such a difference to us as people. He's worked for this organization for 26 years. And he said for 23 of them, it was under different ownership before Bob Chapman came along. And he said, and I would come in every day, I would clock in, I'd be given my notes of the work that I had to do. And I went and did it, and I went home and I clocked out. And he said, in all of those 23 years, I was never once asked my opinion about how we could improve things. I was just there to do my job. And he said 3 years ago, Bob Chapman took over the organization, ripped out the clocking in machines, gave us full ownership of the areas that we worked on the factory floor. And he said, and we can make changes, we are autonomous, we have authority and responsibility. And he said, I really love coming to work now and really enjoy my job. One of the things that we've discovered in Humanising Workplaces, having worked with lots of organisations, and you may well have seen this chart before, is the early adopters group. We always call them the usual suspects. And I've seen a lot of usual suspects with the 3D Crowd project, I have to tell you, down in Devon and Cornwall, etc. And they're the people you really want on your side. So they're the people who are enthusiastic, give their all, fully committed, boundless energy, willing to overcome all the problems that you really want with you when you're trying to initiate some kind of culture change in your organisation. The biggest challenge, and I've experienced it myself many times, being an employee of organisations as well, when you're trying to make changes, is that chasm before you really can start to expand on developing the culture across an organisation. That's one of the biggest challenges, I think, and one of the biggest frustrations you can have. But if you've got champions on your side working with you, you are increasing the chances of success of developing that culture change. And linking this to where we've been over the past few weeks, which has been a very strange time, and I'm sure everybody relates to this completely, that it feels like we've been in this forever, and yet it's only a few weeks. But the thing that struck me and links very much back to Humanising Workplaces is how people have stepped up in a very, very difficult crisis time, have really made a difference in doing some incredible things. And it reminded me of this quote by Steve Jobs, that there are actually, there are people who sit on the sidelines of life and have opinions and comment and point the finger and criticize and, do all those sort of things. But the people that we're really interested in, and it's something that Brené Brown has challenged many times, is the people that get into the arena and actually feel the blood, sweat and tears and are willing to roll their sleeves up and actually get involved in stuff. And I've seen and experienced in this project in the last few weeks so many people that fit this description by Steve Jobs. So for me, I've been reflecting over the last couple of weeks particularly about, looking back to the beginning of this crisis and with the world crashing down around us, and why do people choose to get involved in a project like 3D Crowd UK? I was one of those people. Literally my business ground to a halt 2 days after that and first announcement back in March. And only a couple of days later, I was looking for a purpose. I was looking for something where I thought, I want to break out of just sitting at home. I need to be doing something that's going to help somehow in some small way make a difference to people on the front line. And I came across 3D Crowd's initial call to arms, if you like, right away, and instantly made a decision to be part of all of that. And I love from a guy called Sean Murphy, who wrote a book called The Optimistic Workplace. I think this describes so beautifully what we're in with all of this, that collaboration plus connection equals community. And if you read those descriptions, that's exactly what's been happening for the last few weeks and is happening right now, where, there is a participation of people working jointly together. There's a relationship between people focused on a common goal, and we've created a community of people with that shared interest who are doing some amazing things. It's a great descriptor that describes so well really what's going on. And it never ceases to amaze me how much people give unconditionally if it's for the right cause. This is a guy called Andy in Devon who I've picked up a few times from parts that he's made. And here's Andy not only handing over some parts, but actually giving away some filament. And this has been multiplied hundreds and hundreds of times, I know, right across the country. But the sheer generosity of people has been amazing. I look back on the last few weeks and realised, you know, we've printed a lot of parts, like a lot of other people have. We've connected with dedicated makers all over the Southwest. We found drivers and creative routes and picked up from lots of different remote places. In the last few weeks, we've set up the Honiton Hub to serve Devon, Cornwall and Wiltshire in just a couple of days, thanks to East Devon District Council actually giving us loads of support and the space to do so, and so on and so forth. And I think, you know, some of the things specifically as a shout out is people who've offered their help without being asked. I think about Matty Dredge, wonderful coordinator in Wiltshire, who rang me up at the very beginning because I think he could see from all my Slack questions that I was really lost trying to take on a coordinator role. And he kind of sprang to help, you know, of his own volition. And we've become very good friends and we talk a lot on the phone. And he really helped me get up and running in a few days, just by making a decision to reach out and connect with me. The amount of people who've worked all hours to get work done, and, you know, they've worked long hours into the night to get machines working again and all sorts of stuff. I was blown away by the elastics run that happened from Nottingham to Devon a few weeks ago. I was the last person in the chain to receive elastic. It was organised in just one day and it all went into operation the following day on a Sunday, and it worked like clockwork in getting quite a quantity of elastic from Nottingham all the way down to various hubs and down to Devon. And I have to shout out to my daughter-in-law, Janelle, who's the queen of the elastic cutters, who has cut so much elastic for the hub and enabled us to make so many kits as a result. We couldn't have done it without you, Janelle. That's me and Darren outside East Devon Business Centre. And I have to give credit to my very good colleague, Darren Emerton, who, through a lot of hard work and creativity, has come up with the most amazing processes, like spinning closed baskets to actually dry things off quicker, clothes dryers and curtain wires to actually be able to hang them up and let them dry quickly overnight from the Milton. Works such a treat and actually has improved the process and streamlined the process of our hub in Honiton incredibly in just a few days. I was reminded of this description of a wonderful organisation by Raj Sisodia, if you've come across Raj, who wrote the book Conscious Capitalism. And if you read it, I think it's a true reflection of what we're going through with this project. And I love the second sentence that says, their days race by in a blur of focus, intensity, collaboration and camaraderie. That's exactly, to me, how it feels. And I wanted to just show you a video that you may or may not have seen before by the staff of Dropbox in America, who were given the challenge of producing a video to share their thoughts and feelings about what it was like to work for Dropbox. So here it is.
Why do I love Dropbox? Boy, I mean, if you've got a few hours, I can go over it.
So why do I love Dropbox?
Why do I love Dropbox?
Why do I love Dropbox?
It's a really difficult question. Gotta be the people.
The people.
There's not a bad apple in the whole building. Dropbox is, everyone's positive. I feel like every time I come to work, it's just extremely positive.
I think it's a very human place, if that makes sense.
The culture at Dropbox is down to earth and magical. Lots of dedication, hard work, paired with a lot of fun at the same time.
It's also a culture where people want to deliver on results, but they also never take themselves too seriously. Dropbox is respectful of my time, not only here at work, but also at home.
There is a seamless integration between your life and your work.
It's just such a diverse group of people, and everyone comes together to create this all-star team.
I'm always surprised here at Dropbox.
There's a lot of talk at Dropbox about how great our perks are.
My very favorite perk at Dropbox is the tea and scones cart. You're just like sitting there writing code, and all of a sudden this cart comes by your desk.
The gym is great. It's awesome. I really enjoy the gym and being able to work out and then pump iron.
There's a music room at the office, so I spend a bunch of time there, late nights, playing guitar with folks from work. The one thing that really attracted me to come to Dropbox was this belief that users really own their data.
It's not uncommon that like I'm walking around and I have a Dropbox t-shirt on and somebody will stop me on the street and be like, I love what you build. And I love that. I just love knowing that what I'm building has so much impact on so many users.
One day Dropbox will be such an iconic name that I will look back and be so proud of myself for being a part of the journey.
It all goes back to empowerment and initiative. These things are just core to who we are and the kind of people we hire. It's not only a place where I come to work, it's a place that I come to grow.
Oh my God, I love Dropbox. Is this interview over now? Okay, thanks.
So some lovely messages there, I think, that reflect some of the things we've been talking about. So in finishing my talk, I just wanted to say, through the legacy of my grandmother, Violet Sampson, I reflect on this, that if we start simply by building relationships with others, grounded in trust, we can definitely build amazing environments for our people to grow in and do amazing things. And if you look at the power of what has happened with 3D Crowd UK and this project, as a result of people from all different backgrounds and for different reasons getting involved and coming together to create this community, I think it's incredibly powerful. Thank you for your time today. It's been nice to be here. Thank you.
Thanks very much, Rob. So if anyone else has got any questions, put them in the comments below. To get us started, we've got one from Jake. What advice would you give someone who's struggling to find confidence in themselves?
I think it's a really valid question, Jake, and I would say don't keep it to yourself. The thing that I found, which for us guys particularly can be very difficult, but as I've done it, it's just got easier, is to talk to somebody else. It's that vulnerability thing again. Somebody that you trust. It doesn't have to be somebody that you work with. It doesn't have to be a family member. But if you find somebody that you really trust and value, it's finding an opportunity to talk through with somebody else to build your confidence and to talk about the things that make you feel less confident. If I was to say to you that I've stood in front of really big groups of people and spoken about something I'm really passionate about, if I was to analyze that very carefully, I would lose all my confidence thinking I'm going to be standing in front of a large group of people. But what I found was that being really passionate about what I talk about, you forget about yourself and you find yourself in situations where you can stand in front of people and that confidence thing doesn't go away because you're sure about your message. But I would say very simply, it's don't keep it to yourself. Confidence building, the best way of changing that is being coached or mentored by somebody else that you trust and value. And it will take some time. It will be a series of things to help build that up in small bits over a period of time. But I found for a long time, if you don't speak to somebody else and share that's that vulnerability, revealing yourself as to who you are and saying, actually, I don't feel that confident about this stuff. It's amazing how people will help and support you to build that confidence over a period of time.
Great. Well, that's all the questions we've got, Cyril.
But
thank you very much. It was really interesting.
Thank you, Sam. Thanks for your time, everybody. Thanks. Take care.
So coming up next, we've got our final talk of the day, which is on 3D printing for metal casting from Jonathan Cope. And that will be in 15 minutes at 3:15. Hi everyone, so our next talker is Jonathan, who'll be talking about how he uses 3D printing into metal casting. So over to you, Jonathan.
Thanks, Sam. So hello everyone, my name's Jonathan. Pretty much anyone that knows me calls me Johnny, so we'll just go with Johnny Cope. I'm a maker based in Northwest London, but I'm kind of multimedia in that I work in a wide spread of different materials, but also as well different things. So anything from blacksmithing, silversmithing, leatherwork, woodwork. I'm also part-time extra actor. So, you know, I wear lots of different hats, let's say. In terms of 3D printing, I made my first 3D printer about, must be 6 or 7 years ago now. It was a Printerbot. Tried a few others. I still quite like Printerbot. It's a shame that they failed in the end, though there's signs they may be coming back. So my main printer is a Printerbot Simple Metal, though I've upgraded it. I've done a Z upgrade, a Y upgrade, heated bed, you name it, kind of rebuilt it, re-engineered it, and I run several. And much like many of you, I'm sure, you get a 3D print out, and you know, once you've tinkered with it, and obviously I realise people watching may be complete beginners through to experts and beyond. All being well, you get a nice 3D print, and it's great, and you know, they're wonderful things. And I'm sure many of you have tried different materials, and some of them are very strong. But maybe you've found yourself thinking, "Oh, this is great. Wouldn't it be wonderful in metal?" And I found myself thinking that, not just for the look of it, the weight of it, but if you actually want to get into the engineering side of it, you actually want to make, I know, say a working gear or something that's going to hold some weight, some structure. That's what led me down this path. So how easy is it? Well, it's not without its problems, but I'll explain some easy ways to get into it at the end. I, for a number of years, have had an interest in ancient history, so that was my way into it. So I 3D printed, this is a model of a Bronze Age axe, which would be hafted onto a handle. And who wouldn't want to turn that? It's, you know, really lightweight and everything, but who wouldn't want to make that into ½ kilo of solid bronze? Well, me, basically. So that's what we're going to look at. So I'm going to move over now, with Sam's guidance, to a quick PowerPoint, and then we'll come back to the live feed, and if there are any questions and things at the end. So let me just pop over to PowerPoint. That's working okay, Sam? PLA, as you can see, it's not fantastic resolution. I was impatient. It's probably run at about 1.4, so it could have been a lot better. And I'll talk about that sort of thing at the end. I sprayed it, so I use a standard gap filling acrylic spray to help smooth it, though there's lots of other things we can do, as I'm sure many of you know. And then the cast there on the right hand side. So metal casting. Historically, what we've looked at is, not to get too technical about it, but some folks that know anything about this may be familiar with the term cire perdu, which is just French for lost wax. And that's how things started way back in the very beginning, nearly 2,000 years ago. So you'd make something, a shape in wax, you'd invest or embed that in clay. You would then melt that, which baked the clay, and it melted out the wax. You were left with a void inside, and then you would melt metal and pour it in, breaking open the baked clay, and your metal thing was waiting for you inside. What sort of temperatures have we got to work at? Well, I'm working with bronze, so around about 1,000 degrees C. So, you know, it's not for the faint of heart. It's not without its problems, as I'll talk about briefly in the safety section. Here's some others that you might want to use, or have seen people use, or be thinking about. Aluminium is the obvious one, because it's, you know, it's still very hot, but aluminium is quite cheap. We can melt down cans and things like that. So lots of people doing that on YouTube. The place to start, maybe if you have never done anything like this before, will be so-called white metal, pewter or tin. So those of you that remember D&D, or, you know, metal figures from gaming, from like Warhammer, those sorts of things, that's this tin alloy, and you can get kits for that, which I'll show in my slide. But this is about 200 degrees, So it's a lot more comfortable, a lot more straightforward. So that's probably what I'd suggest a way to start. So what's involved? Rather than doing the clay version or investment casting, which is a castable material, it's a lot more laborious, intensive on time, and more expensive and prone to lots of problems. So the easy way into it is what gets called green sand. This is or Delft clay is another way you'll hear it called. This was used for many years and still is used in the jewelry industry, and it's effectively a sand-like material that when compressed, so hit with a hammer, you can see my little rubber mallet there, it starts to behave a bit more like a solid. So it's kind of more like clay. So what I've got there is a two-part mold, which to use technical terms is called a flask. You'll put the sand, beat it flat, scrape it flat, and then it's kind of like a clay surface. And then you'll take a master, a former. In this case, this is one I already had in bronze. In the case we're giving here, we'd actually 3D print something and we'd lay it up against this material and then hammer it in. So it's part way into the surface. This is what's called parting powder. So it's, talc, effectively a chalk material, which is powdered all over. The second section of the flask mold is put in on top. These have special lugs that hold them in place, so it's all in register. You put in some more of the Delft clay and you hammer it flat. So it's quite a strong process. So your objects have got to be strong to withstand this, and I'll talk about that in a moment. So once it's all hammered flat, then we can release the mold back open. Hopefully nothing falls off and you're left with this nice clean impression. I can lift out that bronze original, which leaves me a void inside, and then reintroduce the two halves back together again and clamp them for safety and just to stop them moving one against the other. And now we've got a finished, ready to go flask mold with, if we look down inside there, we'd see a void down inside. And that's what we're going to fill up. So different ways to make melt metal. I'll talk about this towards the end, but this is how I started. So obviously I'm creating bronze. I'm creating the ancient mix of bronze, which is around 85 to 90% copper and the rest tin. So I take those two and introduce them into a crucible, which can take very high temperatures. They're usually made out of graphite. You can see one just in the far distance there, the little sort of pot standing up inside that green shed area, if you like. This is down in my garden. And the white structure you can see there is effectively a foundry, a melting furnace. I built that out of high temperature bricks, and then I used kaolin wool, which is a more recent product, which is can take very high temperatures. Not too expensive, but you can cut that to shape and fit it around as a thermal deadening layer, so it helps insulate. And I've got a lid on there with a hole to let some of the air in. So I'm started off using charcoal, so I'd set up basically a charcoal fire, a bit like a barbecue. And then you can see this little black pipe there on the right hand side, and it's a vacuum cleaner on blow, as simple as that, and that's blowing air into that rusty looking pipe, which is just what I had to hand out. Like a lot of makers and tinkerers out there, we tend to keep things lying about, whatever, throwing anything away. And that introduces oxygen into this environment, which greatly heats up the charcoal and rapidly builds the temperature up to many hundreds of degrees. You'll see just also up at the very top of that picture a little yellow device, and that is a temperature monitor, and that has a wire which feeds and through a little hole in to the edge of the furnace to monitor the temperature, so I can actually see what's going on inside. I can use tongs, some safety tongs to lift the lid off and have a look if I need, but ideally I want to keep that heat inside. So we're ramping the heat up, and then this is bronze, so it's about 1,000 degrees. I'm using tongs, and as you see, all safety devices, special aluminized gloves there to protect from the heat, because it really does feel very hot. Even on a cold day, it radiates heat towards you lifting that crucible up with the molten metal, and it's quite a magical process of actually pouring that then into this mold, which partly burns the sand, but it very quickly wicks away the heat. So then putting the crucible out of the way and breaking open, I can actually take the original thing out. This was, we've changed now to a different day. This is a little, hopefully obvious, sharp, what's called a tang spearhead. That was also 3D printed from an original, and I made a batch of these that were used in a film where they were reenacting spears from that particular time. So this is then quenching this 1,000-degree cast heat into handleable cold temperature very quickly. It all happens really quite quickly. It's quite magical, actually, seeing the molten metal turn into a hard object like that. So here are some bronze axes of different kinds that started out as 3D prints and then got cast. And then I'm expanding into all sorts of other objects. So the things at the bottom, you might recognize those as Viking Mjolnirs or Thor's hammer, worn by Viking raiders, if you're into such things. We've got a little spearhead over there on the right-hand side, and the little smaller things around are various chisels and razors and so on, with an axe in the middle. So I ran that setup for quite some time, and it was perfectly fine. But then now started to do this sort of more commercially. I also run workshops teaching people how to do this. So just to make it quicker and more efficient, I moved to a propane foundry. So this one was made in Bulgaria. The brand there that you see is called Devil Forge. So it's all a lot more robust. This is a metal shape. With what's called cast refractory inside, so it's effectively like a kind of a high temperature cement, which is then dried, which holds the heat in. Obviously, a little hole to allow the gases and everything to escape, and allow a tiny bit of oxygen to come in. What we can't see hidden behind the white plank there is the propane feed. So you set a burner going in, and then adjust the oxygen that gets pulled in from ambient air, and very quickly again ramps up this temperature. I've created better and better devices to safely lift the crucible out and place it in that big iron there, which lifts it up and allows me to pour it in that waiting flask. So we might not want to all dive into that level because it really takes quite a bit. Actually, I'll just move back to that slide. Just this kind of kit. We're not talking huge sums of money. If you think this is something you really want to do, or have always wanted to try, or think, yeah, that's for me, and you've got the space and the wherewithal to do it, we're talking about £800, I guess, to start buying all this equipment. About 500 will buy you the forge. If you want to start off with this sort of DIY build like I did, then you can cut that down to only a few hundred, some special bricks and so on. So that's a lot more affordable. This sort of thing, you're looking at a bit more, just because it's more professional kit. It's going to last a lot longer and do the job more efficiently. So you choose your level, where you want to be in terms of hobbyist, or whether you're going to use it professionally and so on. But those of you that have bought or built or working on 3D printers, it's not beyond the price of most sort of 3D print setups. Really, it's probably comparable, and very, very similar. I'm sure many of you remember the sort of learning curve. Sort of start off small and then upgrade and add new bits. Well, that's what I'm doing with this casting. So not many folks will want to or need to go straight into casting bronze. So probably won't need some of that setup that I'm showing there. So how can the average person pop into this, start this just at home with simple setup and cheaper? So this stuff is our friend. Those of you that tried other media, if you 3D printing, I find people tend to build in other materials or have an interest in building and making and all this sort of hobbyist level stuff. You might have become familiar with this, which is a silicon-based putty. It's in two parts. In the two pots, you mix it together. And then you've got a certain amount of work time before it sort of sets and it goes sort of semi-hard or flexible. There's different grades of it, but that's really, really useful. So what I suggest as a way to start really is, rather than thinking a fully three-dimensional shape, I kind of work backwards in a way. I dove in the deep end, but that's just me. And then now I've been doing these types of silicon molds more recently, and I'll explain why in a moment. Rather than using bronze, this is, I just took this off the web. This is a typical so-called white metal, pewter, tin, basically, low melt alloy. You can get these kits, you know, looking on Amazon or eBay, you'll buy one of these kits pretty inexpensively. Certainly, you know, 20, 30 pounds will get you a little kit. You see their little metal ladle, some small files for finishing, because obviously nothing casts absolutely perfectly. This one was based on like a modeling clay that you use to invest into or cast into, and then the little bars down there are the actual white alloy material down there at the bottom. So this is the sort of thing you could safely and pretty well do over a home stove. Not so easy on electric. If you've got gas stove, you know, you could easily hold these little things over the gas stove, 200 degrees, it melts pretty readily, and then pouring it into a mold. The silicon that I showed earlier, you can find most of it will be able to tolerate white metal at about 200 degrees. If you want to go a bit hotter than that, you can find, if you look around, some very specialist high temperature silicon, so it's still flexible, and you can put maybe more like aluminium in there. At the moment, I've been looking around, there's nothing flexible, the silicon based materials that will go any higher than about 600-700 degrees. So it's certainly not going to be possible to cast bronze, but some other materials, other metals are perfectly possible. So rather than a full mold, which I showed, this idea of a flask, the metal mold I showed at the beginning, in two halves, which will give you a fully three-dimensional object, I would suggest the best place to start is what I would call a press mold. So this is an object, it's actually a little historical Tudor button, but that doesn't really matter. It could be any little simple shape. So you can think of a coin or a little medal, or the sorts of things that you know, many of us may have seen on Thingiverse. You know, a little commemorative coin or some kind of little plaque, some small, shallow, low relief object. That's the sort of thing we're talking about. And I would suggest probably best place to start is something small. You know, always scale up once you've got the hang of it. Get hold of some of this silicon molding material, figure out, you know, roughly how much you want. I know, maybe a small golf ball size of each, mix it together. You have a look at the instructions, you'll find most of them have got between about a 3 and a 5 minute work time, so you can't kind of leave it lying about. You either just squash it down onto a flat surface, or find a little container, shallow container to push it into. I literally just squash this flat using my hand. A bit like using Play-Doh, and then you take the object, invert it upside down, and then press it firmly into this silicon. Press it right down until whatever the back of this object or coin or flat thing is flush with the surface of the silicon, and then just let it sit there. 5-10 minutes later, you can come back and gently just bend this now very flexible rubbery type mold, and the original will pop out, leaving the little void that you see there. And then laying that on a surface, it was pretty straightforward to use the little pewter kit, like the ones I showed earlier, just to melt some metal and then gently pour it, and carefully pour it into that mold. Give it a moment or two to cool down, or if you're really impatient, you can use gloves and you can pick it up and dunk the whole thing in water. But basically wait till it's nice and cool, bend the mold again, flex out the object, and there you have your little cast object in white metal. And that's very satisfying. It's a really kind of quick, instant process. It doesn't use much at all. And like I said, using a white metal pewter tin casting kit that you could buy right now somewhere like Amazon, £20, probably a comparable amount for a simple silicon kit. So you're looking at, you know, £40–50 outlay, some standard sort of hobbyist things you might have lying around, spoons and spatulas and things like that, a pair of gloves, nothing, you know, too major needed. Most kits will come along with some basic safety advice. Nothing like this gives off any particular nasty fumes, so, you know, standard keep a window open or have some fume extraction, or you know, in a shed if you have the capability to do that. but all pretty straightforward and within the grasp and wherewithal of most of you who've done any kind of tinkering and making before. So I'd encourage you, if that's something you wanted to try, this is the way to start, really. So little sort of summary, really, to put all that together. Start off thinking about simple shapes. If you're looking at the silicon press molds, I would encourage you to start off with the low melt pewter tin. Start small. You can always gear up later, but there are some little learning curves. There's some problems. Why go all guns blazing, something really big and advanced, and it fail, and then you might be put off. So always better to start off a little small, learn the lessons, and then work your way up. Certainly when it comes to the 3D prints themselves, no fine details until you kind of really get to grips with how you're doing this, and that's true really of whether we're doing the press molds or the sand casting or any different way of doing it. Rules that follow all the way through, really, you guys are going to know these, and ladies, very, very well as 3D print enthusiasts. No undercuts and overhangs, even more so than 3D printing. We know there are tricks, with support and whatever, or multi-part in 3D print that you can get around that, but really, it's a lot more difficult to try and use those sorts of shapes. So you need something which is, to get technical, it's bilaterally symmetrical. So think like a bivalve, like a shell, something that is symmetrical both ways around a center point, and without too many protruding parts initially. Something that will come as no surprise really to most 3D print folks, and that is smooth. You don't want rough textures. You can introduce some textures, but it just brings its own problems in terms of how the mold will work. Certainly with the sand, if there's too much texture, that it can't. You'll pull away the sand with that original object as you try and pull it out. So that therefore it ruins the mold, and therefore any cast you're going to make from it. So I'd encourage you to try and start off with smooth things. So obviously, print them at good resolution. Use all the tricks I'm sure many of you know for smoothing. So whether it's acetone, whether it's spraying, sanding, a combination of all of those. I'm in favour of. I don't really like acetone very much. It's the fumes are not very wonderful, and you can over melt your objects. So I sand mine or print them at good resolution, and then I'll give them a good liberal spraying in. You can find some quite reasonable acrylic sprays out there, which are considered sort of filler sprays. They'll actually be sold as that. So they're used for the car industry for repairs. To usually plastic parts on car bodies, so they're thicker than normal paint. They don't run so much, and they tend to fill. So they will fill some of our little lines and things like that to give you a nice smooth surface. The boring bit, obviously safety. I'm sure many of you are, probably under 18, and that's fine. But and if you're a very practical person, and you approach this cautiously, then sure. If there's any under 18s watching, do get help from adults. Do get permission. Really obvious statement there, but some of this can be quite dangerous. You are working with very hot and molten and liquid metal at the end of the day. Even 200 degrees is a very, very nasty burn in the case of the pewter and the tin. So, do be careful. PPE, personal protection equipment. So very minimum, some gloves, protect you from the heat. Burns are nasty, some mask or eye protection. And if you start getting into things like the aluminium or the bronze, like I was doing, you're going to need some kind of fume extraction. Not because it's overly poisonous, just it's not great, some of the fumes. So either work outside, work in a shed, or have some fume extraction involved. When I was looking, like many of us, I went looking on YouTube. There's some great videos out there. Some enthusiasts who looked at this and thought, right, let's have a go. There are quite a few based in America who they build foundries and forges to melt metal. There's seems to be a big activity of melting aluminium cans down, which is great, sort of eco and recycling and all that. Unfortunately, some folks saw the whole thing of sort of Cere Perdue, this lost wax, the idea that you have a wax thing held in some kind of mold. And I think there's some misunderstanding there, and several people risk serious injury by taking a 3D print and embedding it in clay or in the sand that I used, and then leaving it there, and then expecting to pour molten metal in on top. Now, yes, the sort of temperatures above aluminium, it will instantly liquidize your PLA 3D print, but it's going to create gases, it's going to create molten material. That's all trying to fight its way out, a bit like steam in a kettle. So guess what? It comes exploding back out, and it usually bring the metal with it. I'm usually all over you. You know, it might sound like a boring kind of, you know, lecturing dad thing to say, but please, you know, I saw so many people almost live on feeds getting seriously maimed by pouring hot metal on top of PLA or 3D prints. You know, just don't do it. Just never try it. It's unbelievably dangerous. So there you go. That out of the way. Now, I'll come back to the live feed in a moment to field any questions that might be out there, or just chat further. But if anyone wants to just make notes of these or take a picture of it, if you want to connect with me because you want to learn more or take this further, I regularly give courses, so you could come over to my studio. I'm in northwest London near Harrow via Obby, which is my hobby, and the range of workshops and courses which I give, and the bronze casting one has been pretty popular. I can also cover aluminium or pewter as well, how to do that, the whole process from start to finish. Obviously, with the COVID-19 situation, we're not quite there yet. I probably could receive one person and we could safely do that with social distancing, but I think we're nearly at the relaxation of this, that we'll be able to fully start this. And even when it's sort of normal, whatever that may be, I can only have about 3 people at a time anyway for safety. So if that's something that interests you, and that, you know, it's a good way to learn, look me up on Obby and maybe book on a course and come and try it out. If you're just interested in some of the things I make and want to just buy finished stuff, and I occasionally make kits to do these sorts of things, then find me on Etsy. So that's the middle link. And if you want to check out my YouTube channel, you'll find most of that actually is me with my other hat on as a musician. So you can have a laugh at all the crazy things I get up to there. But there are more and more, I'm starting to put some more other feeds on there and other videos about my making and 3D printing and crafting and so on. So you'll find those on YouTube. And finally, if you want to just go ahead and hook up by good old email, I'm johnnycope@hotmail.com. So feel free to send me an email if you have got a very specific question that's not been answered in the session we're going to do in a moment, or just you know, want to maybe ask where supplies come from or something like that. I'll do my very best to answer. I'm kept pretty busy, so give me a day or two, but I'll do my very best to answer any queries that come. So I think we'll pop out of that. I think I'm pretty much running to time. So
great. Well, yeah, we've got a couple of questions for you.
Okay.
So the first one is from Rob. What would you recommend? Well, sorry, would you recommend people start the same way that you did, or is there another way? Anything you'd recommend avoiding when you start out?
I'm one of these people. I tend to go in all guns blazing. I think that's because I'd had a bit of I won't bore you with all the biog, but you know, I've done lots and lots of things in life, and I've done a little bit of casting even way back in school level, back in the late 70s. Yes, I am that old, and we were still doing casting then, so I'd had some practical hands-on, so I didn't feel too much of a stretch. So if you're the sort of person that's had practical hands-on skills, or you've done maybe some welding or some hot work, or you know, you're that sort of minded, you could go straight for the bronze if you like. But I think for most folks, just to reiterate what I'd said previously, just start small, start with the pewter or the tin, low melt or aluminium, you know, make it easy on yourself. Unless it's something you know you're definitely going to do a lot of, then you know, you perhaps don't want to go spending lots of money gearing up to find out then either it's not for you, or it's more involved than you thought, or so on. So yeah.
Great. And we've got another one from Leo of, do you mix your own alloys?
Yes, I do. So I mean, alloys, only really come into play when we're talking about things like bronze or brass. Aluminium is aluminium. So if you're going to melt down cans, the little sort of caveat I'd attach to that is, some of you may know that drinks cans obviously have print on the outside, so that's ink. That's going to liberate some fumes, so watch out for that. And a lot of drinks cans actually, because aluminium is now, they've decided that it's vaguely mildly toxic, so perhaps you shouldn't be ingesting it. They'll be skinned inside with a very thin piece of plastic, actually, in most, say, like a Coke can, so that the drinks are not directly contacting this very thin aluminium. So that will also get burnt off, so that's going to produce fumes. So if you're burning aluminium, be very careful. You want to be outside, you want to be away from it whilst that all gets burnt off. Once it's aluminium, that's fine. You can look up some alloys of aluminium. You can introduce some things into it which make it a bit stronger, or make it run better, or cast better details. Look up those online. Probably haven't got time to go into the detail of those now. For bronze, because I wanted to recreate this sort of ancient bronze, I wanted these axe heads I was making to be as accurate as possible. So I'm making them now for museums and things, and reenactors, so they want to be correct. I wanted to control my mix, so I buy actually just copper pipe that you might find in a DIY shop. I hammer it all flat, chop it up into chunks. I introduce that into my crucible. And the weird thing is, if you try to cast with just copper, it's actually got one of the higher melting points. It's well over 1,000 degrees. But just by introducing between 8 and 10% of tin, that drops down to under 1,000, about 950 degrees, which makes it a little bit more manageable. It's still extremely hot, but that makes a very nice alloy, which casts well, pours well, stays liquid for a reasonably long time, and has some strength behind it. If you have heard the term brass, that's effectively the same mix but with zinc added. Now, I'd say definitely don't do that, because zinc is one of the few metals that when we get it hot, certainly for pouring at melt temperatures, it actually gives off really very nasty fumes. You can actually get zinc disease. It kind of feels like really bad flu, and it's really not very good for your lungs. So be a bit careful, a bit cautious as you get into this. Either ping me an email if you think you want to go that way, or I would imagine most of you will just do some research first before you dive at something like that.
Great. And then I think we've got one final question from Neil. Do you have to do any post-processing to finish off the parts that you've cast?
Well, at a very simple level, and one thing actually, I didn't get a chance to add this to the PowerPoint, so I'm going to answer that in a rather roundabout way, if I may. In that, one thing I forgot to mention was some folks may have come across this before, PMC, which is a modeling clay, which you can buy sort of a copper version of it, but actually silver. So it's a polymer silver in kind of it's a bit like Play-Doh clay, and it presses into press molds very, very well. And you press it in, then you leave it a day or so to dry, and then you carefully pry it out, and then it's a kind of a bit like the air dry clay, like Fimo, that sort of stuff. And then you can fire that using just a blowtorch, the sort of thing that a plumber would use, or you could do it even over a stove, and that sinters down, to use a technical term. It renders down into solid silver, and that actually comes out very clean because of the way it's done. All the other methods we've looked at, you're going to get what's called flashing. So a two-part mold, maybe it leaks slightly at the sides, and where you've poured it in, you've got what's called the gate. You've got the little hole that I'm pouring into, and maybe you pour in a bit extra as well, so you get this little blob at the top called a sprue, and you've got to cut that off. So you might want to hacksaw that off, or use bolt croppers, and then you have to just a little bit of filing, what's called fettling. So a little bit of grinding, filing. Nothing, too massive. It's the sort of thing that you might do to a 3D print anyway, to finish it off. It's only that level of finish. Depends how perfect you want to be. If you want to take the thing to a very high polish, then obviously you've got to start talking about rouge wheels and polishing kits, and it's a bit more involved. But yeah, most things come out. It's usually like a lot of these things, the more time and effort you put into preparing the original, making it really nice and smooth, and preparing the mold, however you're doing it, the clay or the press molds. If you make that nice and accurate and well fitting, then you'll get a good clean cast, and it won't need too much finishing. So yeah.
Great. Well, thank you very much. That's all the questions we've got.
No worries.
Yeah. Thanks for your talk.
Okay. Thanks very much.
Thanks for watching, everyone. So for tomorrow's talk, starting at 10 a.m, we've got a few different topics discussed. And they're including space weather, custom G-code, Project Tetra, which one of our coordinators has been involved in, which is about ventilators. A few people talking about their home printing experiences and how they got into it and the troubles they had, and a few others. So thank you very much. We'll see you then.